Great. Well, good afternoon. On behalf of the Planning Committee, I would like to welcome everyone to what will be our 58th State of the Science Symposium. My name is Paul Pasquina. I am the chair of the Department of Physical Medicine and Rehabilitation at the Uniformed Services University, and also the chief of the Department of Rehabilitation at Walter Reed National Military Medical Center. We started these symposia back in 2004 as a collaboration between the Uniformed Services University, Walter Reed, and my good friend and mentor, Dr. Rory Cooper from the Human Engineering Research Laboratories at Pitt and the Pittsburgh VA. As background, in 2003, we started to receive a large number of casualties from Iraq and Afghanistan that, thanks to the heroic work of our corpsmen, medics, and forward area medical and surgical capabilities, were now surviving wounds that in prior conflicts would have been fatal. As rehabilitation professionals within the military, it is our mission to bring the best that technology has to offer across the United States and across the globe to help our soldiers, sailors, airmen, and Marines recover and thrive after even the most devastating injuries, including those that involve amputation, paralysis, loss of vision or hearing, traumatic brain injury, complex pain syndromes, and mental health disorders, including post-traumatic stress disorder. These symposium were designed to bring experts together across different fields, ranging from traditional medical, surgical, behavioral health, and rehabilitation fields to emerging areas of science, including robotics, engineering, virtual reality, nutrition, neuroscience, genetics, genomics, and now even geroscience, with the intent to fuel cross-disciplinary communication, share best practices, identify gaps in knowledge, and help develop novel therapeutics and interventions. Over the years, these symposium have expanded to broad range of topics with multiple participating institutions and numerous knowledge products and innovations that have helped to educate over 4,000 past participants and enhance the care of countless patients. Today is no different. While we all wish we could be face-to-face in Sanford Auditorium at the Uniformed Services University, because of the pandemic, we have transitioned to a virtual platform, but remain very thrilled to have such an amazing lineup of speakers today, as well as a great turnout of participants. To start things off, and to introduce our honorary symposium chair, Senator Van Hollen, it is a privilege for me to introduce the president of the Uniformed Services University, Dr. Richard Thomas. Dr. Thomas is a graduate of both the School of Dentistry and the School of Medicine at West Virginia University. In addition to being our university president, he is also board certified in otolaryngology, head and neck surgery, and continues to see patients here at Walter Reed in the ENT clinic. He is a retired Major General in the Army, where he served for over 26 years in numerous leadership positions, culminating as the Director of Healthcare Operations and Chief Medical Officer for the Defense Health Agency. During his time in uniform, he deployed across the globe in support of numerous missions, including combat operations in Iraq, Afghanistan, and Panama. He is the recipient of numerous awards, including the Defense Distinguished Service Medal, the Murtha Memorial Award for Leadership in Military Medicine, and the American Academy of Pain Medicine's Board of Directors Award. President Thomas, thank you for your continued leadership at the Uniformed Services University and in military medicine, and thank you for helping us start off this State of the Science Symposium.
Well, thank you, Dr. Pasquina. Can you hear me okay? Just a sound check. Can you hear me okay?
Yes, sir.
We can hear you, yes.
Thank you. I appreciate that. And Paul, thanks so much for the introduction. I want to thank you, both you and Dr. Smith, for this opportunity. And good afternoon, everyone. I'm really impressed by the turnout for today's symposium, and I'm really honored to welcome you on behalf of the Uniformed Services University of the Health Sciences to the State of the Science Symposium. And as you just heard Dr. Pasquina mention, this is the 58th State of the Science Symposium that we have co-hosted since they began back in 2004. Here at the university, the Uniformed Services University, we're always pleased to facilitate bringing together experts such as you. They can come together in multiple disciplines and advance discovery that will hopefully enhance the lives of all of our men and women in uniform, as well as their family members. And today's symposium is no exception. We're very pleased to be sharing the podium today with our collaborators from the University of South Carolina, the National Institute on Aging, and the Human Engineering Research Laboratories. And as you all gather here to discuss, to define, and develop a proposed national framework for the newly emerging field of geroscience. Ladies and gentlemen, today I have the distinct honor of introducing our guest speaker, United States Senator Chris Van Hollen. Senator Van Hollen started out his in public service back in 1985 as a legislative assistant for defense and foreign policy under U.S. Senator Charles Mathias. And he later served as a professional staff member to the U.S. Senate Committee on Foreign Relations. In 1989, he became a legislative advisor for federal affairs to the Maryland Governor Schaefer. And just 3 years later, he was elected to the Maryland State Legislature, first in the House of Delegates and then later in the State Senate. In 2002, he was elected to represent Maryland's 8th Congressional District, which includes the Uniformed Services University. And while in the House of Representatives, he served as a member of the Democratic leadership and was elected by his colleagues to be the ranking member of the House Budget Committee. He was reelected 4 times from this very district by more than 70% of the vote. And then back in 2016, he was elected to the United States Senate and is now a member of the Senate Appropriations, the Budget, Foreign Relations, and Banking, as well as Housing and Urban Affairs Committees. Senator Van Hollen is a graduate of Swarthmore College, as well as the John F. Kennedy School of Public Policy at Harvard University and Georgetown University Law Center. And he's been a member of the Maryland Bar since 1990. Senator Van Hollen has an extensive background in defense and foreign policy, as well as education, finance, energy, and the environment. With institutions like the Uniformed Services University, the National Institute of Health, the Walter Reed National Military Medical Center, Johns Hopkins, University of Maryland, and numerous biotech agencies in his state, Senator Van Hollen is also a staunch advocate of medical research. And throughout his career, he's been a tremendous supporter of military medicine and specifically our Uniformed Services University. Ladies and gentlemen, I'm very pleased to welcome our honorary chair and speaker today, Senator Chris Van Hollen. Senator?
Well, thank you, Dr. Thomas. Can you hear me okay?
Sir, I've got you loud and clear. Thank
Great.
you.
I just wanted to check. It's great to be with you, and I'm joining everybody from my Baltimore office. And I want to thank Dr. Thomas. I want to start by thanking you for your leadership at the Uniformed Services University. This is a great national treasure, and we're grateful for your leadership. I'm very pleased to be joining all of you for this State of the Science Symposium, and I do want to applaud the extraordinary work of 2 leaders joining us from the National Institute on Aging at NIH, Dr. Ferrucci and Dr. De Cabo. They've not only been instrumental in setting this conference up, but also, and most importantly, advancing geroscience, and that's of course, the topic of today's symposium. Let me also give a shout out, as Dr. Thomas did, to the other main organizations involved here. I mentioned the National Institute on Aging and USU, also to the University of South Carolina, and to the Distinguished Scientific Review panel. Finally, I want to thank Dr. Bennett and all his colleagues from the University of South Carolina, Dr. William Kennedy Smith, for his leadership in conceptualizing this symposium, and to Dr. Pasquina for coordinating the involvement of USU and for his many decades leading the delivery of rehabilitation care to our wounded warriors at Walter Reed. and to everybody else who helped make this symposium and gathering possible. You're bringing together thought leaders and experts and the brightest minds in this field from around the country. And we're honored to have you all converging here in the state of Maryland around three of our nationally, in fact, internationally important institutions, USU, Walter Reed, and NIH. And I do want to thank Maryland scientists and researchers for all the contributions they make to our country. Maryland is a locus for so much of this scientific exploration and discovery, home to over 1,800 life science companies and over 70 federal labs, and of course, federal agencies that are essential to the issues of public health and medical research in the United States and across the globe. And all of you who are gathered here, who are part of that scientific community, I think recognize the extraordinary effort that went into developing new vaccines and therapeutics to fight COVID-19 at a lightning fast pace. I mean, at record development, and now, of course, because of the good work of those researchers and scientists, we can see light at the end of the tunnel in this pandemic. And as we beat the pandemic, more and more people are getting back to work. So thank all of you. And I think it should give the public faith in the investments that we make in our public health system and in our medical research. And of course, that also goes for the important work being done to improve the overall quality of life for aging seniors who make up an increasingly large percentage of our population. In only a few years, it will increase dramatically. By 2040, there'll be about 82 million older Americans, twice the number from the year 2000. And the 85 and up population is projected to more than double from 6.4 million in 2016 to 14.6 million in 2040. And God willing, I'll be part of that contingent. And so the work that you're talking about and the work that you're doing is something important to all of us and so many of our loved ones. We've got to, break out of the status quo. And I know that you're going to be focused on how we can take a giant leap forward when it comes to addressing care for our seniors. And I do believe that the power of American innovation plays an essential role there. Geroscience holds vast potential for raising the quality of care, lowering costs, and improving the well-being for our older citizens, all at the same time. And I look forward to your input as I work with my colleagues in the Senate and the House to make any necessary public policy changes to support your work. This kind of work requires progress in both the public and the private and the nonprofit sectors. We need to nurture an ecosystem that includes biotech and healthcare companies, commercial markets, venture capital and philanthropy, academic institutions, and government and regulatory agencies. And all of you play an essential role in focusing our efforts along those lines. As you know from his statements and his budget proposals and other initiatives that he's put forward, President Biden recognizes the need to tackle these issues. If you look at his most recent proposal, the American Jobs Plan, he takes an expansive view of what infrastructure includes, to include the infrastructure necessary to care for our senior population, to provide people the alternative of having more home care provided, and to making sure that we have a workforce that can accommodate and address the needs of an aging population. He's also been focused on trying to make the investments necessary in important areas of medical research to try to take a quantum jump forward. I was honored to join him and members of the House and the Senate, Republicans and Democrats, about 10 weeks ago, as we convened in the Oval Office to discuss his idea of creating an ARPA that a DARPA-like organization that focuses on medical research. And the vision there is to make quantum leaps forward in areas that show real promise and potential to address major healthcare challenges. That includes diseases from cancer to Alzheimer's to diabetes and other diseases that both have exact a terrible toll on our loved ones, but also have huge costs associated with care. And so I look forward to working with him and my colleagues on both sides of the aisle as we put that idea into action. The idea would be to create this separate agency that on the defense side, as you know, was responsible for important breakthroughs in everything from the internet to semiconductors to GPS systems. Not a substitute for the ongoing medical research at NIH, but under the NIH umbrella, another agency designed to turbocharge those areas that show the most promise. So I look forward to getting your input on all dimensions of these challenges, and just again close by thanking all the partners who came together to focus on these important issues, and thank you all for convening around three national treasures that also happen to have their home in our state of Maryland. USU, NIH, and Walter Reed. And I wish you all a very good discussion and conference. And I really do look forward to any recommendations you have, both across the board, but specifically any ideas you have as to how the Congress can be helpful. Even in a very politically polarized environment, the kind of work that you're doing is the kind of enterprise that can unite the country behind big ideas. And so thank you very much. And I will turn it back over to Dr. Thomas.
Senator Van Hollen, thank you so much for that. And before we go back to Dr. Pasquini and the team and Dr. Smith, I want to really sincerely say how much I appreciate your continuing support for and your leadership for not just military medicine, but all the research efforts that we have here. And so we look forward to actually living up to the challenges. I think you just laid out the challenge for all of us. And we look forward to working with you in the future and appreciate the opportunity. Thanks very much. Paul, how about back?
Thank you.
Well, thank you both President Thomas and Senator Van Hollen, for getting us jump started here. It's really an honor to have you both participate. This idea of aging, just as a background, we held a State of Science conference about the issues of aging with a disability, because as you know, many of our servicemen and women that we're taking care of with severe injuries have challenges with aging. And I never thought that we would be at war and receiving casualties for as long as we have been. But now, as you're taking care of patients that you've seen 20 plus years ago, you really are compelled to try to figure out what you can do now that might help them retain function later on in life. And that was actually a conversation that that Dr. Smith and I had over the past several years now, and it's my pleasure to introduce him as our key leader in this State of the Science Symposium and moderator for today, Dr. William Kennedy Smith. I had the privilege of meeting Dr. Smith 15 plus years ago as we worked together on various projects to improve the care of individuals with traumatic amputation and brain injury. And I'm pleased to say that over the past 15 years, he has become a very close friend to me and my family, and I appreciate that. He is someone that cares deeply about helping others, and is particularly skilled at bringing together teams of experts around a common mission and to help solve complex problems. Dr. Smith, like me, is board certified in physical medicine and rehabilitation and holds a certificate in lower extremity prosthetics from Northwestern University. In addition to being an assistant professor at the Uniformed Services University, he is also an adjunct professor at the University of South Carolina College of Pharmacy, with a focus on the development of therapeutics that target the aging process. Dr. Smith has an extensive track record of accomplishments in the areas of disability, resilience, and rehabilitation. He founded Physicians Against Landmines, which, as a member of the international campaign to ban landmines, was a co-recipient of the 1997 Nobel Peace Prize. I should probably stop right there, but I'll go on. He organized the first meeting and was a founding steering committee member of the International Disability Caucus, which represented civil society groups in negotiations for the United Nations Convention on the Rights of People with Disabilities. As a researcher, Dr. Smith has led teams to first place finishes in 2 Veteran Administration Innovative Challenges and has served as the principal investigator on multiple multi-year grants from the National Institute of Disability and Rehabilitation Research, the Department of Defense, the Department of Veterans Affairs, DARPA, and the World Bank. He served as a principal investigator at the NIDER Rehab Engineering Research Center on improved technology access for landmine survivors, designated a National Center of Excellence in Rehabilitation Engineering. He conceptualized and led the design and delivery of the world's first distant learning course in prosthetics, which was certified by the International Society of Prosthetics and Orthotics and successfully delivered a 7 war-affected countries. In 2007, Dr. Smith led efforts under the World Bank's Emergency Disability Project to deliver training to over 100 Iraqi health professionals working with war wounded for the Iraqi Ministry of Health. He has served on the faculty of Northwestern University, where he taught courses on disability and international law. Dr. Smith, thank you first and foremost for your friendship, but also for your leadership in putting together such a great program and moderating today's symposium.
Thank you, Dr. Pasquino. I was trying to interrupt you to say stop, but I thank you very much for the very kind introduction, and also for your friendship and for the opportunity of working with you at USU, which has been a wonderful, extraordinary experience with you and Dr. Cooper and all the terrific colleagues that you bring together around such an important mission. So grateful for that. So I'm going to try to sort of weave in and out here a little bit to help the speakers by introducing them briefly. And I hope I'm not going to be able to go on with that length of introduction. But of course, I'm very grateful. But basically, you know, this has been an extraordinary experience working with so many professionals and the people who are on here today. And one of the conversations I had around this meeting is about contemplating a federal investment in geroscience. And we'll talk a little bit about what that is. But a friend, Terry Lehrman, reminded me of a comment made by a woman named Mary Lasker, who was a great humanitarian, a family friend of my family's, who had a lot to do with NIH in the 1970s. And her comment was that investment in health research is about dying young, as late in life as possible. And that's a terrific summary, I think, of the intent of a lot of the conversations today. And when I reported that comment to Dr. Ye, who's our first speaker, she said, there's something missing. And the missing piece is with joy. And so I think the topic of aging is fascinating. We're going to have 3 parts to the conversation. The first part of the conversation, we're going to talk a little bit about the experience of aging, which is very different. It's not about how old you are. There's a lot of factors to it. It involves diet, health, exercise, attitude. And many of those issues have been thoroughly explored by our first speaker, Dr. Charlotte Ye, who is the Chief Medical Officer for AARP. And, my analogy is always that aging is, the last great challenge we all have in life. And it needs to be approached with the same seriousness and planning that the rest of the challenges that we take to life involve. And in a way, it's the last mountain we climb, and it determines as much as anything our legacy in our life. And so I consider Dr. Ye a guide and, to climbing that mountain. And she's been doing that work for millions of seniors across the country. She's a medical doctor as well, emergency medicine trained. And it's my great pleasure to introduce her now, Dr. Charlotte Ye.
Wow, my goodness. Thank you. Thank you so much for the kind introduction. I just want to say it is such an honor and a privilege to be part of this symposium, both personally and professionally. I am thrilled to see your call for action and investment into the science of aging. And just as an aside, knowing uniformed services are part of this, as an emergency physician, we learn so much from the military. And my hope is as we dive into geroscience, we will gain the expertise and knowledge that we can give back to the military for what they have given to us. So as we move forward today, I do have one ask, and I'm going to be sharing my screen. But I do have one ask of each of you to please keep your mind and your mindset open. Do not be bullied or lulled into continuing that perception of aging as negative, that it's all about decline and loss that we have to fix. As you explore this area of geroscience and a deeper understanding of the biology and the mechanisms of aging, can you pay attention, as Dr. Smith said, to the joy, to the wisdom, to the experience, to the assets, to the positivity of aging? Now, I'm sure you're saying, what does she mean by this? Like, what is she talking about? Well, I don't know how many of you have seen this study that was done and published in the Gerontologic Society of America, looking at the US population and asking about, do you have health-related limitations on housework or on work? And of course, in your 50s, 90% say, no, I don't really. But how many of you, when you get to 85 and older, remember 85 and older is the fastest growing population, say, that it applies to 85 and older, and yet 56% of the population, 85 and older, say, I have no health-related limitations on my work or housework. Is that your common perception of aging? When we looked at our ARP-branded Medicare supplemental population, over half of them said, my health is better than other people my age. Why are we not looking into what is behind that? The CDC, similarly, before the pandemic, they follow, mental health, stress and anxiety and depression. And here's a study from 2019 looking at, in this case, anxiety, but it holds true for depression and other mental health disorders, that age appears to be a protective factor. With any severity, mild, moderate, or severe anxiety, the older you are, the less distress you have from anxiety and depression. Why are we not looking into what is it that brings that kind of resiliency? And even in the pandemic, we know that it has highlighted all the vulnerabilities in healthcare and our healthcare system, including specifically for older adults. But if you look at mental health, and we know that mental health burden, stress, anxiety, depression, social isolation, and loneliness has increased dramatically as a result of the COVID pandemic. But if you look at it by age bands, it hits the Gen Z the most, and the least affected population is actually the older, the baby boomers and older. We looked at these protective or positivity factors in our ARP branded Medicare supplemental plan. We have about 4+ million members. And we just said through survey work, and we've been following this over the last several years, let's just take a look at some of the positive and protective factors. And these factors were 5 that we looked at, specifically resilience, optimism, locus of control, purpose, social connection. And what we found is it didn't matter which one you had, but the more you had, the better your self-reported depression. It's almost like a dose response. It's a linear correlation. If we looked at depression, similarly, the more positive resources, skills, capability, attitude that you brought to the table, the lower your rate of depression. Similarly, with health self-reported health status, there was much less fair and poor reported health status. And speaking of rehab and functionality and limited capability, the more positive attitude of resiliency, locus of control, sense of purpose, a social connection, and optimism, the better your self-reported functionality. And it wasn't just about function, but also about healthcare outcomes, but it also affected cost. This is, again, very linear, almost like a dose response. It didn't matter how many of these 5 resources or protective factors, or I actually call them the personal determinants of health. It didn't matter which one, but the more you had, the lower your healthcare costs. And for every added resource you added, there was a reduction of $1,356 in healthcare costs and expenditures. And what could that mean to us? We have about a little over 4 million, actually 4.4 million members in our Medicare plan population that's administered by United Healthcare. If in each of these categories, we had about 20% that had no resources, 20% with one, in each of these categories. What if we just took the people who had no skills, who just were at the bottom of the pile of resiliency and being able to think positively about aging? If we just added one factor and saved $1,356, that would be $1 billion in 1 year. If we took the entire Medicare population, 46 million, we're talking up to $12 billion. So as you look into the science and the geroscience and the biology and the metabolism and the epigenetics, can you not only explore all the negativity and the decline and the loss and the cardiac disease and dementia, but can you also look at who are these people that are adding strengths and what is the biology that we can tap into, and not just be a risk reduction, but a strength building approach. This matters, and I want to go back to this perception and positive perception of aging. It is not just lifestyle. It is not just diet, exercise, alcohol, smoking that we commonly talk to about medicine, but it is the entire attitude and the social constructs and the messages that we give. Right now, AARP has done a survey with the University of Michigan, and 88%, almost 9 in 10 older adults say that they are commonly exposed to ageist messages in materials they watch and they read every single day. Over 80% say that they have seen things like, being older, you're a joke, right? I've fallen and I can't get up, I can't hear. And it is not just, what you think and you feel, but it's what you actually see. For example, if you look at advertising, over a third of advertising for use of technology shows young people being very capable with technology, and yet less than 5% of ads ever show an older person being comfortable with technology. But we also know from the SAFE survey that 2/3 of people 50 and older say that being over 50 was actually better than they expected. The sad part is we are already at the stage where 1/3 of people 50 and older have begun to internalize these stereotypes of negative aging and say that being lonely, being depressed is inevitable, it's inherent to growing older. And in fact, the more you watch media, 4 hours or more, the more you watch it, the more likely you begin to internalize this negativity of aging. And I just shudder to think during this pandemic when we're watching all the streaming and all the ads and we're doing nothing but staring at our screens, what this impact might have on our future health outcomes and the cost of care. Why? Because we know that as those with a negative perception or negative attitude of aging are less likely to fully recover from disabilities, more cardiac disease, more dementia. And those who have a positive view of aging actually have a 55% lower rate of hospitalization. And it's not the outcomes, it's the money. So in our Medicare, Medigap population that we looked at, Already 40% of our 65 and older have a negative view of aging, and they cost us 33% more per member per month. I know we all talk about loneliness, we talk about social isolation. In our same population, about 20% are severely lonely. They cost us 20% more per member per month, but look at that negative perception of aging and 33%. So I'm sure you're looking at saying, well, what can we do about this? I think we could start. I love this example by the city of Boston, and they started this in 2019, before the start of the pandemic. And they said, why should we talk about, being elderly and senile and the decline of aging? What if we change the name of our Commission on Elder Affairs and called it the Age Strong Commission? And that's exactly what they did, and started this incredible advertising campaign that I'm showing you posters from, that were on the buses, on the subways, at the airports, on TV, in the magazines. And they highlighted ordinary Bostonians. And they took such things as words associated with being old: cranky, frumpy, definitely, old style, childish, we're not active. And took these people and said, I am many things, but cranky isn't one of them. Frumpy isn't one. And my favorite is Irene, who's 103 years old. She's a little over 4 feet tall. She is the most dynamic, cute little woman who lives in Charleston, one of the communities within Boston. And she said, you think I'm out of touch? Whatever. I use a smartphone, paint every day, play Sudoku on my tablet, spend time with my boyfriend. I'm many things. And senile isn't one of them. So this general perception that is out there in the community is what we need to address as you explore your science of aging, to make sure that we are including the communications, the social messaging, the social networking, the social media of how we perceive and do or don't respect aging. What I might ask of you is to think of people like my father. He's here, he's 92 years old. So this picture is of him at 90, dancing at my nephew's wedding and with my niece. I don't know about you, but at 90, how many of you can do that kind of a deep knee bend? He is doing Zoom dance lessons with his granddaughters. He is still exercising an hour a day. And he's got a cochlear implant, extraordinarily hard of hearing. And yet this past year, he's learned to use an iPhone with captioning. And lest you say, well, maybe that's just genetics, and we know that there are social determinants. Not everybody has access to this. Just remember, my father lived during the Japanese occupation. He's lived with discrimination when he immigrated to the US. There were times in our family where there wasn't necessarily enough food in the house. And yet he somehow has been able to thrive. And ARP has taken on this message. We, for example, have banned the word with Allure magazine, the word anti-aging, from all advertising, from all articles in a beauty magazine. So my ask and my question as we go back is, as you dive into the science of aging, the therapeutics, remember, it's not just drugs, but it's the interventions. Can you tell us if it's ever too late? If you didn't learn resiliency as a child or in the military, is it ever too late? Can you translate that basic research in science into actionable, clinical, community, and frankly, individual programs? Can we talk not about aging in place, which I hate that term, but about thriving in motion, that with purpose and people, where possibilities are endless? Can we actually use the geroscience and the science you learn to not just be about the absence of disease, but about the joy of life, the joy of aging, the assets, the wisdom, the positivity. If this is what you can do with your investment, with your science, not just the negative side, but the other half of the coin, the positive side of aging, we will have just a wonderful science and a future we can all be proud of. So with that, Dr. Smith, thank you so much for the introduction. Thank you for allowing me to speak to just some of the best scientists here on aging.
Thank you so much, Dr. Ye. That's a great way to start. And, you know, I want to just introduce a couple of concepts before introducing our next speaker, because we're going to hear a lot about lifespan, and people think geroscience is about living longer. But I think the key concepts that are coming across early in this meeting apply more to health span, that period of life where you can have the basic functionality necessary to enjoy life and to participate. And when health span and lifespan segregate or depart or part company, it's a tragedy. You know, my mother passed away from Alzheimer's this past year. It's a very difficult disease, and I'm sure every one of these panelists could share a similar story. And so it's that period of time between health span and lifespan. I think it gets back to the point about dying young, as late in life as possible, that really represents the key focus for a lot of the efforts I think we're talking about today, whether they're, you know, psychological or quality of living or biology. And there was one person who asked the question, you know, what if we took all these diseases that are impacting people as they get older, heart disease, cancer, stroke, Alzheimer's, pulmonary disease, the major causes of death and illness in our country. And what if there were an underlying process that we could identify to push that back, to make us feel and be biologically younger longer? It's a key question that lies at the heart of all the science that we're going to hear about today. And our next speaker, Ronald Kohansky, was one of the people who first asked that question in a formal scientific way back in 2007. He's the director designate of the Division of Aging Biology at NIA. His research accomplishments are far too long to list. And so I will only add that he is not only a terrific scientist, but just a great scholar in general, with a terrific interest in Shakespeare, and I'm sure we may even hear a quote or two, but it's my great honor to introduce Dr. Kohansky. Dr. Kohansky.
Thank you very much. Thank you for the opportunity to speak at this event. Along with Felipe Sierra, who was the director of the division before me, we did start the Geroscience interest group. It was largely Felipe's idea, but I helped him along the way and then inherited that. But the concept of geroscience actually started with Gordon Lithgow at the Buck Institute, who presented that neologism to the world. And it is really, what can we do to understand the good things and the bad things that happen during aging, and what can we find in those who are aging well, if I may use that term, and those who would benefit a bit from some kind of intervention. So around here to this. So based on the previous presentation, there are two ways of looking at the circumstances. One is the glass half full, and is the glass half empty. And for those of us who look at it more on the half empty side, we'd like to know how to finish filling it for everyone. Some age well, and some could benefit. So there is a view, admittedly somewhat dismal, about the way things go with biological aging. And that is, you have living, which we all do. And we do things during the day, and we do them as well as we can. And we do them year over year, and we expect that we'll continue doing them well. And a lot of the things that we do during the course of the day are metrics of health. And with aging, longitudinally speaking, we might think that we're in better health than our people at the same age. I'm pretty sure I'm stronger than most people at my age, but I'm not as strong as I was 30 years ago. That's a fact, something that annoys me endlessly. But your activities are harder to do. And they are actually harder to do year to year, again, for any particular person. So in the biology of aging, we are looking at the study of declining function. So the biology is the study of things that are required for a living organism, and the biology of aging is as those decline. So there is a view that damage accumulation underlies a lot of the biology of aging. It's a valid viewpoint. It has a lot of currency. But in this simple diagram, you can ask how to understand biological change as the years pass. That you have a biological system that works with pretty good efficiency. Not 100%. There's nothing in biology that's either 0 or 100% as long as you're alive. The efficiency comes from macromolecules that are synthesized. They have a regular turnover rate. They are made, they are removed. They don't have to be damaged to be removed, but there's a regular turnover that goes on. And on that side of the equation, things are working well. But as damage begins to accumulate, so the theory goes, and you have to remove the damage, if the removal becomes inefficient, you begin to accumulate damage, which leads to some inefficiencies. And if the damage overwhelms the system, either the ability to remove or the ability to buffer the damage, you end up with deficiencies. And many of those deficiencies underlie some of the difficulties that people do experience at older ages. So the way biology of aging is organized, it's in one way anyway, is based on the work published in 2013 by Lopez Otin and colleagues, and that is the hallmarks of aging. They have 3 critical characteristics. One of them is it's a biological event, generally deleterious, that does increase with age. If you exacerbate that hallmark, you will accelerate aging. And we see this in disparate populations, for example. Anywhere along the life course where they have been subject to chronological stress or multiple acute stresses, it does have an impact on a person's lifespan and how well they enter and survive their older years. There are many exceptions. People have a great deal of resilience, and there's a range of resiliencies. But if you ameliorate the hallmarks, you can expect that the rate of aging will be slower. So the basic observation is that in adulthood, the observation of geroscience is that aging, a process, is the major risk factor for loss of function and increased susceptibility to disease. And the goal of geroscience is testing the hypothesis, if you slow the rate of aging, vis-a-vis these hallmarks, then you can delay the appearance and reduce the severity of disease. So you ask, do the biological changes have causal roles in loss of function? Are they permissive of the loss of function or advent of disease because something else is occurring, such as a genetic mutation that's manifest later? Are they instructive in the way that cells instruct each other during development? They may instruct each other during aging as well. Or are they coincidental? If it's coincidental, maybe it's a reporter of the aging process, but it might not be a driver. But the key outcome is to get better health at older ages. So you may ask, if you're going to have an intervention to improve health at older ages, what are you looking to do? And among the hallmarks are a guide for this. Are you removing senescent cells as a way of developing a therapeutic, lessening fibrosis, et cetera? I'm not going to go through the whole list, but you can always add your own ideas in place 11. So here's an outcome from the intervention testing program where lifespan was the metric, but the key point here is not that these mice live longer when given rapamycin. They are more active. They are, by all appearances and all metrics, healthier. So these are 2 mice at the age of 30-something months. They're quite old. So when you come to doing an intervention in the human population, well, we live a lot longer than mice. We can expect to live into our 80s by and large, some shorter, some longer. So how do you do this geroscience intervention for people? Well, generally speaking, you would do an intervention by looking at the distribution of age types. So some people look younger and some people older at any age. We know this very well from the Dunedin study, now 45 years in the making. And if you do an intervention, you want to ask, are you getting somebody who looks older to look younger, whatever the look means, better function? Or are they just staying where they are? Some will benefit, and some will be relatively neutral. But how long might you expect it to take? Well, we live to quite an old age, but there's research from the University of California that says you can estimate a rate of aging in 2 to 3 years of clinical visits. There's even evidence from the Dunedin study that you can do it from a single measurement at any time. So in summary, this is a view of geroscience. It's basic research on the biology of aging, biology of dysfunction, and the biology of disease, how they meet together. It's translational research at its heart. How do we help people do better in their lives? And so the geroscience is, in a sense, prevention research. How do we help people maintain their health for longer? And that's the goal, to achieve more health at older ages. Thank you.
Thank you, Dr. Kohansky. Thank you very much, Dr. Kohansky. This exercise involves a conversation between a number of different groups, and there is an extraordinary number of distinguished scientists who participated in preparing or contributing to a white paper that goes along with this conference. Any one of them could have given a presentation. This is not fundamentally a state of the science presentation conference, but we did want to have some flavor for the kind of and the quality of research that's currently taking place in the field. And our next speaker is eminently qualified to give us an example of that. Anna Marie Cuervo is an MD PhD and the Robert and Renee Belfort Chair of the Study of Neurodegenerative Diseases at Albert Einstein, a professor at the Department of Developmental and Molecular Biology and the Department of Anatomy and Structural Biology, as well as the Department of Medicine and Hepatology. She has an extensive background in molecular structural biology. She has been involved in studying neurodegenerative diseases, including Parkinson's, Alzheimer's, and Huntington diseases. And I will not go through all of the specific focuses of her research, but I'm hoping she'll give us a sense, and I know she will, of the wonderful work that's going on in the field that really has the profound implications that I think have led a lot of the political leadership to look at this field as a serious possible site for federal investment. Dr. Cuervo.
Thank you so much, Will, for the introduction and also this opportunity of telling you why we are so excited about keeping cells clean in the context of aging. As we just hear from Dr. Kohansky, the major goal of biology of aging research is really to uncover the molecular and cellular mechanisms that contribute to aging with the idea of modulating them to improve health span in our elders. And he showed another rendition of these hallmarks of aging, but just to illustrate where our research falls, we are interested in proteostasis. And I know that half of the audience is already worried about this awful word, but it really refers to quality control inside the cells. So when you think on your cells, it's a very packed environment inside. All the proteins, all the organelles are so close to each other that it's essential that each of them is on the right place at the right moment and in the proper conformation. And to ensure that that's the case, all the cells in your body contain a surveillance mechanism that is called the proteostasis network that is gonna be sampling what is wrong, and that's the job of the chaperones, and if they can repair it, that's okay. And if not, they eliminate it through these proteolytic systems. There are different ways of how you can eliminate proteins, but in our lab, we are interested in lysosomes that you remember from your biology class were the garbage containers inside the cell. And when they eliminate this garbage, these damaged products, is what is known as autophagy, or eating parts of the cell. So this process of autophagy happens continuously in all the cells of your body when you are young and healthy, and you eliminate anything that should not be there in the cells. However, as you get old, this cleaning doesn't work so well, and you start building up toxic products. And it sounds a bit abstract, but this is actually on the basis of diseases that we all care very much, such as, for example, Alzheimer's, many of the diseases of aging. So our lab has been interested in understanding autophagy, and something that we have done recently is trying to develop tools to measure autophagy in vivo in a whole animal. So here I just showed you one of these animal models in which we measure one type of autophagy that is called chaperone-mediated autophagy, CMA for short. And each of these dots, bright dots, corresponds to sites of cleaning. Every time that you see that, that means cleaning is happening on that particular lysosome. And we can even go to single cells, for example, neurons, the cells in your brain. And highlight where is this cleaning, where is this autophagy happening, as you can see here. So taking advantage of these models, now we can start seeing whether autophagy really decreases with age in all the organs and when does it happen. And for example, Mathieu and Aurora have been looking at young, healthy animals compared to old. And as you can see here, there is a really reduction in the number of sites of cleaning, on the number of lysosomes that are doing autophagy. And the same is true if now we use some of these mouse models that recapitulate some of the features of Alzheimer's. If you compare, this is a healthy animal, and you see the dots, the points of cleaning. But when you look in an Alzheimer model, you do not see that, suggesting that both in physiological aging and age-related disorder, you see this decrease in autophagy, in cellular cleaning. But does it happen in people? So of course, we cannot use these reporters yet in people, but something that we have done is to develop a mathematical model that allows us to infer the activity of autophagy in samples from people. For example, if we just look at healthy individuals with different ages, two parts of the brain, we can see that similar what I showed you in the mice, there is a decrease, a gradual decrease in this autophagy index with age. And actually we can do the same in the brains of the Alzheimer patients. And if we look at this activity in different stages of the disease, again, this cleaning decreases gradually with the progression of the disease, and it inversely correlates with the pathology. The less cleaning you have, the higher is the pathology on those individuals. So we hope that those tools help us in the future to see if what we see in the mice and what we see experimentally also recapitulates in patients. And of course, now that we know that autophagy decreases with age and age-related conditions, we have three main questions. We want to know why does decrease, why does it doesn't work so well as you get old, what are the consequences of not having this autophagy, and also can we do something about it? So of course, there is a lot of biology behind our studies trying to figure out what is the problem in autophagy with age. And I'm just gonna highlight that in one of these types of autophagy, this CMA that I mentioned before, we found that the point of entry into the lysosomes, this protein that is here depicted in the cartoon, decrease. The levels that you have on your lysosomes decrease with age, so you have less access to put the garbage inside. So taking advantage of this biology, now we can say, okay, what are the consequences of not having that cleaning? Let's reproduce that in a young animal, let's reduce their autophagy and see what happened and whether or not it resumes to an aging. So if we do that, if we reduce autophagy in these animals, these are young animals, we start seeing features like this. You see degeneration in many tissues, loss of function, you see alterations in metabolism, including metabolic syndrome, very similar to what we see in elders. You see a decrease in stem cell activation, and you see an increase in the incidence of cancer. So as you see, these are many features that we see in our elders, especially this gradual loss of function. So then, of course, the most important question is, can we do something about this? And we have engaged in different approaches, but the first thing we wanted is to have a proof of concept to convince ourselves that maintaining good autophagy till late in life is a way to preserve functionality and have people like we hear from Charlotte that at 102 are still able to use their iPad. So to do that, what we have done is, since we know what is the defect now, we can just try to correct it. So we know that this receptor that I mentioned in lysosomes is okay till midlife and then start to decline. So what we have done is adding an extra copy of this receptor that we only activate when the endogenous one start to go down. So then we can compare what happened to animals where we preserve good autophagy per life with animals that are the normal ones in which activity decrease. And this is work from Imata said. And when she looks, for example, at lifespan, here you see males and females. So in blue are the normal wild type animals where autophagy is gonna go down with age. And in orange, you have those ones in which we have preserved autophagy. And as you see here, not only they live longer, but they also seem to increase the mean lifespan. So to make sure that they were living longer, but in healthy conditions, we team up with Rafa de Cabo that has this wonderful battery where you can measure frailty, the index of frailty, similar to when geriatricians do it in the clinic. And I normally used to show tons of graphics showing this frailty index, but I think a picture is worth 1,000 words. So these two animals are the same age, that will be like 28 months of age. And when you look at this one, this is the wild type, it's balding, it has white hair, the whiskers are disappearing, when it walks, it's wobbling. And this guy is the same identical age, and we have just maintained autophagy. So I think in this case, this is the type of things we want to have, improve functionality and maintain an animal in these conditions. Unfortunately, we can still not do gene therapy the way that we are doing in the animals in old people or elders. So can we develop some drugs to do that? And in collaboration with Evris Gabatiotis at Einstein, we have developed now some molecules that can activate this particular type of autophagy. And just to show you something different, I'm going to show you how we apply to one of these age-related disorders, in this case, the same mouse model that I showed at the beginning of Alzheimer's. So what we have done is compare the Alzheimer mouse model in normal conditions, or when we treat it with this activator of autophagy for 3 months. And when we look at the animals, they have better memory. The ones that receive the treatment, they have less anxiety, they have less depression. So all the behavioral aspects seems to be improved. But to convince ourselves that this was because we were cleaning the brain of these animals, then we look at the presence of this toxic protein, tau, that has been associated to the disease. So if you compare in a healthy animal with the one that recapitulates features of Alzheimer, all these black spots corresponds to this abnormal tau protein that is building up in the brain of these animals. So then the question is, can we, by adding this drug, by treating with these drugs that is going to enhance autophagy, clean up some of this accumulated protein? And this is what we found. So of course, there is a very clear evidence that is cleaning, and I'm fully aware that this is a mouse model and we are still long from translating this to humans. But at least it tells us that by acting on the defect that we have identified in aging, or the change that we have identified in aging, we might be able to improve functionality, and in the case of the disease, also reduce pathology. So just to summarize, I want to emphasize how important is to do basic biology research to really understand what are the bases, the molecular and cellular basis of these changes that we see in aging, and use that biology to study the consequences, and also make sure that those mechanisms really translate in humans. And I think this is an area that we probably all should start thinking more and more. And then using that biology to drive this drug development to try to preserve normal function in aging. And of course, I cannot live without saying that in addition of drugs, I think there is a lot of potential for lifestyle interventions, at least in the case of cellular cleaning, because autophagy can be modulated by many different changes in lifestyle. And this is the most important slide, just to acknowledge the terrific people in my lab that every day try to bring new ideas and energy, exceptional collaborators, and of course, people who supported our research, in particular, the National Institute of Aging. Thank you so much.
Thank you, Dr. Cuervo, so much for that incredible overview. And also for just the opportunity to work with you a little bit on this seminar. It's been a complete pleasure. The first scientific investment of the United States government was the Old Naval Observatory in Washington, D.C. And the moons of Mars were first seen from there. The telegraph was laid out from there, establishing time zones in the United States. The Western states were laid out from there. And so scientific investment has been a part of the United States since very early on. But it doesn't happen without people like John Quincy Adams or Thomas Jefferson, people who operate at the margins between science and public policy. And the next two speakers we have have had very distinguished careers doing precisely that. And I think they're going to talk to us today a little bit about the opportunity that this moment presents in terms of some of the federal initiatives that might be relevant to advancing this field. The first speaker is Tom Khalil. He's the Chief Innovation Officer at Schmidt Futures. I frankly came up with the idea of this after listening to him speak at the NIH Geroscience Summit in 2019, where he proposed a science and technology initiative in this area. Tom knows a lot about science and technology issues. Under the Obama administration, he worked to develop the BRAIN initiative. He's done science and technology issues under both the Obama and Clinton administrations, including nanotechnology, as I mentioned, BRAIN, and several others. He has been one of the folks who has identified geroscience as an area that could potentially benefit from an investment at the federal level. He's been a visionary in many other areas, so we're very pleased to have him here to talk about it today, Tom.
Super. Well, thanks so much for the opportunity to talk, and thank you for your leadership on these important issues. So what I'm going to talk about is what a national science and technology initiative is, and why I think the field of geroscience might be ripe for something like that. So a national science and technology initiative is a mechanism by which the executive and the Congress will establish priorities for federal R&D investment. It's usually multi-agency, so it involves more than one agency. It usually comes along with a targeted increase in federal funding for that area. And it also is accompanied by an effort to establish a research agenda, to identify gaps in the current research portfolio, and then to propose investments to address those gaps. There's important roles for the White House, the Congress, and the agencies and the research community in terms of making this happen. It often requires or benefits from policy entrepreneurs and champions who are willing to stick their necks out for this, and can not only benefit from federal action, but efforts to get not only agencies, but companies, philanthropists, universities, regions, and nonprofits involved as well. So I'm going to talk about a couple that I've been involved in. So one that I worked on in the late 90s, and which was announced by President Clinton in January 2000 in a speech he gave in Caltech. It was called the National Nanotechnology Initiative. It's still going on. It's resulted in $31 billion in funding, and has resulted in not only increased fundamental understanding of nanoscale phenomena. So it turns out that if you make something small enough, not only is it small, it has novel and potentially useful properties, and people are developing all sorts of applications for this. So the mRNA vaccines that many of you have been taking have been benefited from nanotechnology, and in particular, these sort of nanolipid delivery mechanisms for the mRNA vaccines. The BRAIN initiative, which folks mentioned, this was announced in 2013. Here the goal was, could we do for neuroscience what the Genome Project did for genetics by not only sequencing the genome, but driving down the cost of that from 100 million to 1,000. So what are the new tools that would enable us to understand the brain in action? So right now we can measure the activity of a small number of neurons in high levels of temporal and spatial resolution, or we can take a fuzzy picture of your entire brain using something like fMRI, but we don't have the ability to measure the real-time interactions of large-scale neural circuits. This was an effort that involved NIH, DARPA, NSF, and IARPA. The Big Data Initiative, which the administration announced in 2012, which was improving our ability to go from data to knowledge to action. So huge amounts of data coming at us in real time or near real time, lots of variety in that data. How do you somehow manage to derive actionable insights when you're talking about huge amounts of data? So you, in other words, in order to make the case for something, you've got to have a rationale for why this is an area that should be supported. And I think there's a really strong case for geroscience, both because it has the potential to increase health span and allow Americans to lead longer, healthier lives. But there are all these exciting fundamental advances that are being made in terms of increased understanding of some of the hallmarks of aging and why we think now is the right time to invest. It's important to have goals for these initiatives. So, for example, the goal of the Sunshot Initiative, announced during the during the Obama administration by the Department of Energy, was make solar cheaper than coal by the end of the decade. So one could imagine something like a goal of increasing health span by a certain amount, increasing the percentage of octogenarians that are leading healthy, active lives, and then progress on particular diseases of aging as well as potential goals. It's important to strike the right balance between setting ambitious goals to generate excitement and convey a sense of the promise while not engaging in hype. So one of the things that the field of AI has suffered from is that the first proposal to develop the field of AI suggested that this would be resolved by the summer in 1956. And obviously it's taken us a lot longer than that. So a lot of times you do have a certain amount of backlash because people overpromise. And then you not only need these like very high overall goals, but you need specific scientific and technological sub goals. Like we'd like to be able to discover and validate biomarkers that can be used as surrogate endpoints for clinical trials. So let's assume that you've made the strong case that we should have something like this, that we have a compelling why now story, that we've got some overall goals. Then the question is, what is it that you want the federal government to do? So, for example, if you had the participation of NIH, of the foundation for the NIH, which allows for public-private partnerships, for the FDA, as sort of the agencies that clearly have an important role, potentially other agencies as well, the various parts of DoD, the ARPA-H that my good friend and colleague Mike Stebbins is going to talk about. What is it that you would want the executive branch and the Congress to do? And so these are a couple of examples. So additional fundamental research, applied or clinical or translational research, platform technologies. What's the equivalent of the $1,000 genome for the field of geroscience? Supporting high risk, high return approaches, which is something that ARPA-H might be particularly good at doing. Different modalities of funding and even novel funding mechanisms. So one that has been proposed by Adam Marblestone and Sam Rodriguez is focused research organizations. So university adjacent temporary research nonprofit organizations that can tackle a problem that can't be done in either industry or academia. Regulatory science. So this is something that the FDA does. So assume that the FDA has to make a decision where there is no good science in order to support that. So giving the FDA funding for regulatory science related to geroscience, I think could be high impact. Research infrastructure, data, computing, new animal models and pre-aged animals, supporting the educational workforce needed for geroscience, dealing with the ethical, legal, and societal implications, like how do we have equitable access to health span intervention, given that we already have, significant differences in lifespan and health span among Americans. And then areas of policy that go beyond R&D, like FDA regulatory guidance, regulatory pathways, CMS reimbursement policies. So these are all examples of some of the potential building blocks of what a national science and technology initiative would look like. Then you've got to figure out how much is it going to cost? What would we do under high medium, and low scenarios? How would we have evidence that this is a proposed increase that the research community can effectively absorb? Addressing governance issues. So for example, what's the right division of labor between the different agencies? Should we have some sort of advisory board or mechanism for the federal government to get external input from subject matter experts? And ideally, you would have multi-year congressional authorization and support from appropriators for this. So for example, one of the things that was very useful for the BRAIN initiative is that the 21st Century Cures Act included 10 years of support for the NIH component of the BRAIN initiative, and also ongoing support for precision medicine and the President Biden's cancer and moonshot issues. As I said, there's not only opportunities for the government, but what President Obama used to call an all hands on deck effort. So opportunities for philanthropy, impact investors providing patient capital for startups, patient groups, so patient enrollment in clinical trials and authorizing data sharing, and companies to identify areas for pre-competitive collaboration in the same way that the NIH Accelerated Medicines Partnership has done pre-competitive work on target validation, or the Biomarkers Consortium has done work on the discovery and validation of biomarkers, which is going to be another key area. For those of you who are interested in learning a little bit more about the policy entrepreneurship process, I've written an article that at least covers my own experience about how you go from an idea to something happening in the world, and how you build a coalition of people in the government, in the executive branch, in the Congress, the private sector, academia, patient groups, philanthropists and foundations, all the stakeholders that would need to come together to make something like this a reality. I would say, I think a major challenge at this point is that although the Congress has been very generous with the National Institute on Aging, that increase in funding has been earmarked almost exclusively for Alzheimer's. And I'm a huge fan of support for Alzheimer's research. So I support the decision by the Congress to provide more funding for Alzheimer's. But I think that there's a strong case for Congress to provide additional support for geroscience. And I think they are inadvertently preventing or making it more difficult for the NIH to play a leadership role in this area. And I think it's not a state secret about why this is, which is patient groups discuss a particular disease that they have. So they go to members of Congress and say, I or a loved one has Alzheimer's or cancer or type 2 diabetes. They don't say, I'm getting older and I'd like you to do something about that. So I don't think that there has been the necessary effort to increase the level of awareness on the sort of key authorizers and appropriators about all the exciting work that is going on in the field of both fundamental and translational geroscience. And I think that there needs to be an effort to both develop a strategy for what it would take for the United States government to do, and to get the leadership of the executive branch and the Congress to support that. So I want to thank Will, your leadership on pulling everyone together, and I think there's an exciting opportunity here. Looking forward to the conversation.
Tom, thank you so much, and for all your work. And part of the, I think there's our next speaker. Can you, part of the, so I met our next speaker very briefly. I met our next speaker when he worked as assistant director of the White House Office of Science and Technology Programs under the Obama administration. And I consider him a friend. And he has been someone who has worked very closely with my cousin, Patrick Kennedy, on issues of mental health. And he is a very trusted advisor and has maintained a terrific relationship, working relationship, I think, with President Biden. And I think the first time we met, maybe we were introduced by then Vice President Biden. But he has been instrumental in helping to communicate the potential of the Advanced Research Project Agency for Health, which has clearly become a key initiative of the administration. And I think high risk, high reward, and innovation, which are two words associated with the Defense Advanced Research Project Agency, could also be associated with Geroscience. And I think there's perhaps a match there. And I think it would be very helpful for all of us to hear a little bit more, including me, about the agency and some of the vision behind it. So I'm very pleased to introduce Dr. Mike Stebbins. Mike.
Thank you, Will, and thank you for the nice introduction. Tom's talk was a perfect segue into what we're talking about next. First, I'm going to apologize a little bit. I'm a little under the weather because I got my second COVID vaccine, so and I got a snoring dog behind me, so I hope that isn't too disruptive. So with that said, I'm going to launch into a little bit of history on why we think that we need a DARPA for health. We were calling it HARPA, but the administration has settled on the name ARPA-H. Either way, I think we're headed towards something great here. So with that said, there are about 10,000 human diseases. We have interventions for maybe 500 of them. There's a massive market failure in the middle of the biomedical research enterprise that we don't talk enough about. So current federal investment strategies created the valley of death, but they do not adequately address the market failures that are in the center of this of the enterprise. ARPA-H would do for health what DARPA does for defense, that is to specifically create and deliver clinical solutions. ARPA-H would also bring a different set of tools and approaches and focus to the development of new platform technologies and capabilities to transform medical innovation. This is through time-bound, milestone-driven innovation, and is proven approach for driving innovation at other agencies. So a little bit of a history on how we got to where we are today and how we got to the president mentioning it in his joint address the other day. So we started about 4 years ago with the Suzanne Wright Foundation approached me to discuss how we might start to address some of the challenges in and around pancreatic cancer specifically. Over the last 40 years, we've made a tremendous amount of progress on other cancers and other diseases, but the death rate for pancreatic cancer had remained pretty much the same. Their idea was to add more additional funding to the NIH, but when discussing it, we thought really what we need to address is the market failure that's preventing these kind of investments in areas like geroscience and like pancreatic cancer that we're not seeing to date. During the Trump years, we made a tremendous amount of progress. The president was personally very interested in this, but we got a lot of pushback from the NIH, mostly because we had a Republican lobbyist who was suggesting that the dollars for funding ARPA-H should come out of the National Cancer Institute budget, which was of course something that very few of us supported. So soon after that, and at the beginning of the Biden campaign, we wrote a white paper. My team and I wrote a white paper and put it out through the Day One project. This is a project that is actually funded by Schmidt Futures, but is something that I think everyone should check out. It's a home for really great and innovative policy ideas, and a lot of them are focused on science. So I hope everyone will take a moment to check that out. It's my plug for them. They've been doing great work. Soon after that, I joined the Biden campaign, and that's where I wrote up the proposal for creating an ARPA-H, or a DARPA for health, which made it soon into the Biden transition team's portfolio. After that, the president started talking about it in his speeches, and it came out in President Biden's skinny budget, and then his joint address to Congress the other day. So that's a brief and history of how we got there. But what are we actually talking about? So if the federal government can address the massive market failures at the center of the healthcare enterprise by establishing an agency who's a DARPA for health that is similar to what we've already done with other agencies. So we've done this for infectious disease with BARDA. We've done this for energy with ARPA-E, Homeland Security and HSARPA, and then IARPA for the intelligence community. So the idea here is to start to address the issues that we talked about. DARPA was established in 1958 It's responsible for, as Tom was mentioning, for the internet stealth technologies, radar, GPS navigation, night vision, autonomous vehicles, and the Moderna vaccine. Through their initial investments in Moderna and mRNA vaccines, we would not be where we are today if it was not for the investments of DARPA. And this is actually a great example of the synergy and the complementarity between DARPA and the NIH. If it was not for the investments that the NIH had made in understanding the spike protein and understanding novel coronaviruses, we would not have been able to make an mRNA vaccine either. So it's the combination of the two that is so powerful. Either one on their own does not actually get us where we need to be. So it's designed to make pivotal investments in breakthrough technologies for national security, directly address market failures that are impeding innovation. So one of the drivers of DARPA is the Hallmeyer Catechism, which was developed by George Hallmeyer while he was director of DARPA. But in essence, this is a series of questions that program managers ask of themselves when thinking about funding a project. What are you trying to do? How is it done today? And what are the limits of current practice? What is your new approach and why do you think it will be successful? Who cares if you're successful? What difference will it make? What are the risks? How much does it cost? How long will it take? And what are the midterm and final exams or checkpoints or goals that you would set for such a grand challenge? So this is why it's important to start thinking about how they complement the NIH. So NIH funds basic science and clinical research through grants. Grants are typically awarded to individual projects at academic institutions. You all know this. Collectively, we form the bedrock of our knowledge about biology, health, medicine, and disease. Without the NIH's funding, there's no point in setting up an ARPA-H. And there's no point in taking money from the NIH to fund an ARPA-H because the two are complementary. ARPA-H will provide the sustained drive to need to push through challenges and achieve medical breakthroughs by building new platform technologies. This is key. The president is focused on cancer and Alzheimer's in particular. I think he's doing that because of his passion for addressing those particular diseases. But the idea here is to invest in the platform technologies that are difficult to fund through traditional R01 grants or through the private sector. The US healthcare system largely relies on private sector leverage the investments in basic research and develop commercially available treatments and cures. But this model means that diseases for which investments are risky or downstream profit potential is low are often ignored. Antibiotic resistance is a great example of that. And there's often underinvestment in platform technologies. ARPA-H will step in where private companies do not, addressing market failures with direct investments that ensure that all patients have hope for a brighter future. So how would ARPA-H function? How is it different from the NIH? Instead of grants, they give out contracts that are large enough to provide a bolus of dollars to drive innovation. There's minimal bureaucracy, and they take a portfolio approach to high risk, high reward efforts. This is what Tom was referring to earlier in funding high risk, high reward research that is goal oriented. Government controls the contracts. There's no traditional peer review. There's top-notch talent. The program managers at DARPA are world-class. They're extraordinary, but they're high turnover. They're only there for 3 to 5 years, tops. Most of them leave around that time. The not-so-secret sauce is that all funding allocations will be left to the discretion of the ARPA-H director. So again, there's no traditional peer review. All funding oversight would be entrusted to ARPA-H program managers. The funds would be awarded as milestone-driven contracts that give the program managers the capacity to early terminate if a particular project is not yielding desired results, or to pivot a project as well. This is something that can't be done with traditional grant funding. This almost never happens. So in the president's budget, there was some language that you guys might have noticed. A $6.5 billion to launch ARPA-H under the NIH, which is fantastic. A focus on cancer and diabetes and Alzheimer's. And then part of the 51 billion request would put it under of the NIH would put it underneath the agency, which is novel and something that we're going to have to explore what that looks like. I think there are some arguments on why it should be at the NIH. Number one, it's the most expedient way to get this done. It requires an appropriation, and then they're off to the races. The NIH is obviously where we fund biomedical research, and that's extraordinarily important for keeping continuity and for keeping close collaboration between ARPA-H and the ICs. But why not at the NIH? There's a cultural difference between what an ARPA looks like and what the NIH and what other traditional grant funding agencies look like. And so you'd have to, in order for this to work, we're going to have to wall it off and have it function through using other transactional authorities. They're slightly different from the way that we run traditional grants. And I've gone through some of those. What happens next? It's in the hands of Congress right now, and there's a robust conversation happening on whether this should be at the NIH, how many dollars it should be, what kind of direction they should have, whether it will be earmarked to work on cancer and Alzheimer's, or whether they'll allow it to work more broadly. But this robust conversation is likely to result, because we have bipartisan support for launching ARPA-H, in the creation of a new federal agency within the NIH in 2022. So with that, I'm happy to answer any questions if people want to email me directly at mike@mikestebbins.com. But that's a little bit of background on where you're hearing the ARPA-H proposal coming from.
Mike, that is an incredible presentation, so informative, so timely. And I think it fits perfectly with where we're headed with our next speaker. So there was an earlier mention from Tom Khalil about somebody has to stick their neck out. And the person who really stuck his neck out today is our next speaker, because he backed the idea that we should have this kind of consensus dialogue around geroscience. And that's always a tricky thing when you're operating within the federal bureaucracy, as our next speaker is. But we have been working with a very broad community, over 35 members of a scientific review panel, to pull together some basic goals and vision for a potential geroscience initiative in order to conduct the kind of outreach on Capitol Hill and to the AARP community, others, to introduce a broader audience to the topic of geroscience and to better articulate the potential benefits and risks that can occur from a federal investment in this area. And so the person who's really been responsible for today and really for a lot of this process in terms of giving it the green light is Luigi Ferrucci. He is an MD, PhD. He is scientific director of the National Institute on Aging. He is a senior investigator for longitudinal studies at the NIH. He is a geriatrician. He is an epidemiologist. He has been involved in longitudinal studies for many years on aging. He's played important roles in the advancement of epidemiology and demography as they relate to aging in the United States and Europe, including studies such as the European Longitudinal Study on Aging, the iCare DeCamano study, and others. His research involves investigating the causal pathways leading to physical and cognitive decline in older individuals. He has continued his efforts to understand the process of aging in both the United States, where he serves as the scientific director for NIA, and also in Italy, where he does many things that I can only guess at because I've seen him zooming from there in lovely locations in Tuscany and Florence. He is a man of many talents and great charm, and it's been my pleasure to work with him on the symposium. Dr. Ferrucci.
Hi, let me see if I can share my screen with you. Okay, can you see my slide?
Yes, we can. We can.
Okay, great. Dr. Smith, Dr. Pasquina, President Thomas, Senator Van Hollen, all the organizers, speakers, and participants. It's really with the pleasure and honor that I'm presenting this extremely high quality meeting. I am incredibly impressed by the vision that have been shown here by the previous speakers. And I hope I can convince you in my presentation that an investment in geroscience is probably the most important investment that our society can do to improve the health and quality of life of the population, not only in the United States, but around the world. I am talking here on behalf of a number of investigators and other entities that have worked on this white paper on a national investment in geroscience. And here in the first slide, I want to outline what's really the main scope of this white paper: to develop and solicit community feedback on a model national science and technology initiative designed to rapidly advance the scientific understanding, regulatory framework, and workforce engagement necessary to translate the promise of emerging geroscience research into the reality of clinical care in the United States. Of course, when I was in elementary school, people told me that you need to write sentences that are only 5 or 6 words at the most. But I think that this long sentence truly summarizes in a nutshell what we want to accomplish here. And the premise to this conversation, it really comes from the epidemiology and the demography. We all know that there is an expansion of the older population in the United States and across the world. But what is really people don't completely probably grab is the fact that the oldest, those 80 and older, those 85 and older, are growing at the rate that is much higher than the rest of the population. And this is a very, very special population that we will see before, because it's really there in this older population that there is concentration of frailty, disability, and multimorbidity that both impose a burden to a single individual and their families, and also on our healthcare system. And the growth of this older population will continue to expand this burden unless we can do something to slow it down. And why we have accomplished so much in disease prevention by focusing on a specific disease, this trend is slowing down. And unless we find an alternative to this approach, it will be difficult to create an margin to this growth. I will show you here what I say that these represent a substantial burden on our healthcare system. You know, these are the cost, average annual healthcare cost for Medicare enrollee age 65 and older. And you can see that the amount of dollars that are responsible for it's much, much higher and increased tremendously according to the age of the population. And there is a trend of expansion that is completely explained by the demographic transformation that our population is going toward. And this is not only occurring in the United States. This is globally occurring all around the world with a very large heterogeneity of the speed of aging across the different countries. This is the world in 2015, and you can see that you know, most of the age 60 and older is by 10 and 30%, but there are many, many countries, both in the United States and both in the America and in Europe, in China, in the Asian country, and also in South America, that will be where the over 60 will be more than 30% in the near future. How do we approach that? How do we take this transformation into account when we look at the future, when we prepare ourselves for the future? I have to tell you a very small story. When I was 15 years old, I met somebody at the dinner. I was serving dinner for the Red Cross, and there was a man on a table on the side, and he looked at me and said, "What do you do here on Saturday night? You are 15, you need to be out having fun." And I said, "I want to do something important. I want to donate some of my time so that the world could be a better place." And the man told me, "If you really want to do that, what you need to do is to dedicate your life to the study of aging, because that is the event, that is the force that will transform our society, our economy, the structure of the family, our healthcare system. And I became at age 15 enthusiastic for this work, and I'm still enthusiastic 50 years later about the potential of applying this science to improve the health of the population. We age very differently. You know, I think that's why I presenting you a global phenomenon. Certainly, there are people that age better or worse than others. And we can see this every day in front of us, in our life, in our friends, in our parents, and in the people that walk around us. Part of it is certainly genetic inheritance. There are people that seem to be predisposed to age better than others, but the amount that is explained by genetic is really small. What we know now is that the life event, the exposure, and many other characteristics, including our health behavior and our access to healthcare, strongly affect the quality of aging and create a health disparity that it's really tremendous. And you know, as we prepare ourselves to approach the problem that affect the older population, we need to consider this disparity as a very, very important issue that we need to take into account. As I was telling you, we all age differently, and I want to show you how, you know, when we take, we always think in terms of people that are affected by more disease, you know, people that are early in developing cardiovascular disease or cancer or respiratory disease. And this is a map of longevity in the United States. And this map at the first sight show you that when you look at, you know, life expectancy, you know, you see that there is a distribution that is not an equal distribution across the country. There is a part of the country where there is much lower life expectancy than in any other places. And when you look at the map, for example, they look at lung cancer, you can see that you know, there is so much analogy in the geographical distribution between the longevity and the lung cancer, but this same we can see in mortality rate, and this same we can look by hypertension. And if I want to show, I had the time to show you other disease such as you know, COPD or myocardial infarction or chronic kidney disease, you will see the same distribution. So in a way, we don't age differently because of specific disease, but we age differently because the force of aging, because the rate of aging is different in different individuals. In part, as I said before, because of genetic predisposition, but in large part because of different environmental exposure and access to healthcare. When you look at the aging process, we need to look at aging in terms of lifespan. You know, one of the things that is really striking is how, you know, our mobility, which is probably is the most important of our function, improved tremendously over the few years of life. And then this mobility tends to be stable. We seem to be able for a long period of time to maintain a normal mobility in daily life. And then at some point, there is a decline. We are accustomed to talk about aging only for this part of our lifespan. This will be incredibly wrong because we know now that aging is hiding in our body. Damage is accumulating over the entire lifespan in our body. And what happening later in life is a consequence of this damage accumulation that is occur in this preliminary period. The problem is that we're not able really to detect what is our resiliency, what is the damage accumulation that is occurring in this period of life. We're not able to measure the pace of aging in this period of life. And so that it's very difficult to do prevention or to intervene in fact and events that we cannot measure. So at least in part, part of the solution is to try to understand, what happens in our body when we are still apparently healthy. And I want to put this in a very, very simple, terms. When I go to the doctor because I'm doing my check of my health, I'm 67 and I'm sent home, say that your blood pressure is good, you don't have high cholesterol, you run every day, you walk, frequently, your diet is good, your exam is okay, so you can go home and be healthy. And that really makes me mad because I'm sure that inside my body, there is something that is already occurring, and that will be important to understand, individualize what these events are so that I can prevent what will happen in the years to come. Many diseases increase in prevalence and incidence with age. And here I presented a few of them and showing you that, the rate of increment of disease, of course, not for substance abuse or for depression, but for many of the disease increase with aging. And that already suggests that they're not separate, but they're connected by some underlying force that we're really not understanding at this time. And in fact, if you look at not a single disease, but a multimorbidity, which is the number of coexisting disease, you can see that the number of coexisting disease increased tremendously with aging. But what is even more important is the rate of accumulation of multimorbidity accelerate with aging has become much, much faster in older age. And in fact, we do know that in some individuals, this rate is much higher than can be predicted by pure chance, suggesting that there is an underlying cause. When I was preparing these slides, I wanted to explain this in a very, very practical terms. And here I have outlined, three patients. And I'll tell you that these are patients that come from my memory when I was practicing geriatrician. And so let's say that we have a period of life that we will call disease-free life expectancy, where there is no emergence of disease. This gray area is the accumulation of damage that is not still emerge as a disease. And so we are apparently, thinking that we're healthy. But at some point, one disease become evident. This, for example, is osteoarthritis. And so that we need to deal with these diseases that are coming. And one of the approach of the past has been, well, what would happen if we could eliminate osteoarthritis? And people think that if you could eliminate osteoarthritis, your disease-free life expectancy would be very, very, very long. In reality, because these fascicles of disease are evolving in parallel, almost together, if you eliminate one disease, you will see another disease coming up. And if you eliminate this, will be another disease coming up. We as geriatricians see this all the time. We cure one patient to see the patient going home and coming back after 2 weeks because they have developed another pathology. But what I want to show you is that there are two cases. One individual that has a long free life expectancy and one that is a shorter life expectancy. But what is really happening is not a single disease is anticipated or delayed, but is the disease together that are driven by the force and the pace of aging that are evolving together. And so the real intervention that we need to have is to try to address this underlying mechanism. And this is important because, as I told you before, we are aging at a very, very high rate. But if we look at what we're gaining, that is one of the strongest success. Our survival is the success of, the human evolution. But in reality, the year that we're living without disease, we're not gaining very much. Most of what we're gaining for multiple disease is disease characteristic life expectancy. So we are gaining in the healed part of life instead of gaining in the healthy part of life. And that is a trend that in somewhat need to be stopped. So a few facts, 80% of the Medicare beneficiaries have 2 or more chronic disease. And I want you to think that most of the books that talk about disease and that I studied with when I was a physician talk about one disease. And the people with one disease are very, very, very few in old age. Multimorbidity is in fact the most prevalent chronic disease. And in many cases, we don't absolutely know how to treat it. And it's a strong landmark of poor health status in older patients. And that is where Geroscience shows its power. Geroscience postulates that the biological mechanisms of aging that have been illustrated so nicely by Ron Kohansky and Anna Maria Cuervo create a global susceptibility to disease that lead to multimorbidity, eventually to frailty and early mortality. And this is important. I showed you before, if you look at the number of chronic conditions in Medicare beneficiaries, you know that the percent of beneficiaries with multiple chronic conditions, 6 or more, is 14%, but they absorb 49% of the total expenditure. So it is in this part of the population, in the part of the population that develop multiple chronic disease, that we can make the strongest impact in terms of relieving the effect. I don't have a slide that is more recent, but the most recent data are even more, impressive. So Ron was talking about the different hallmarks of aging, so I don't need to go through them. But what we know, for example, is that the different hallmarks of aging are implicated in multimorbidity and disability, and especially in one effect that seems to be over the board in the aging process, which is chronic inflammation. Even individuals that are free from chronic disease have chronic inflammation in old age, but those that accumulate disease have even more chronic inflammation. And the impact on the biology of aging on multimorbidity is explained so well by the fact that the typical biomarker in inflammation, which is interleukin-6, not only is a strong predictor of the rate of change in multimorbidity, but the change over time in this parameter is also independently associated with the rate of multimorbidity. And even when we talk about prevention, we are accustomed to think about prevention in terms of specific risk factor associated with one disease, for example, for heart disease. In fact, when we look at the literature more recently, we find that there are risk factors that affect all chronic disease. And in fact, there is no specificity. In most cases, most of what have been identified as risk factor for specific disease are risk factor for general development of disease. But do we have an alternative? I think that there is another way. I think an alternative, I would say a parallel strategy, because we shouldn't stop looking at specific disease. What we are gaining is tremendous, but we need to have a parallel approach that is aimed at slowing the broad effect of aging on chronic disease by interfering with the fundamental basic mechanism of aging that increase our risk of developing this disorder in the first place. If we slow down aging, then we will prevent all these diseases and their consequence, not only on life expectancy, but also on the quality of life. But can we slow down age? Is that something that we can do? If you were talking to an epidemiologist of 30 years ago, they will tell you the aging is something you need to account for in your analysis, because aging cannot be changed. So in fact, it's a confounder. But this paradigm is falling apart. We know, for example, that there are many conditions that accelerate aging that are related to what have been called the pillars of aging. And there is a fantastic program that has been developed at NIA, the intervention testing program, that is starting to experiment, intervention that can slow down aging in animal models. I don't really have the time to go into the detail, but the rigor of this program is just extraordinary. Not only look at multiple sites, the same intervention need to work, in multiple experiments. There is a rigorous control of dietary and hospitally condition. And so far, there are 6 agents that already been discovered that can slow down aging in mouse models. The most important, probably paradigmatic one is certainly rapamycin, that have shown to slow down aging by, reducing mortality in this cohort of mice. But what I want to show you here, that to me is pretty important, very interesting, that you don't see an incredible effect on, whole span, the maximum amount of life that these mice can live. But much more, many of the mice live up to old age. So the curve of mortality is kind of tend to be rectangularized. And that's exactly what we want. I think that if you ask to an older person whether they want to live 200 years, they will tell you that you're crazy. But if you tell them, do you want to live healthy up to 100 years, they will say, oh, that is a promising, objective, for my life. People don't want to be dependent from other people, want to enjoy life up to the last period of their life, as a Texan told me once, dying with the boots still on. And these are other results from the intervention testing program. I'm only showing this to you because in many, many cases, intervention that affect survival are sex specific, have different effect in male and female. And so even when we study aging and when we study the biology of aging, it remains incredibly important to understand that that the men and women are biologically different. And so they need to be represented both in our study, in our clinical trial, which cannot make the assumption that what works in one sex will also work in another. How do we implement that? One of the problems is that we have a system that is being set on disease. And if you go to the FDA, for example, there are illuminated people that understand exactly what I'm talking about. But in general, if you talk to FDA, they want an intervention that target one specific disease. Their paradigm is based on one disease. And so it's difficult to create a culture that switch from the single disease to the paradigm of geroscience. And I'm trying here to summarize what the geroscience intervention will look like. It will be something that, first of all, need to change the balance between damage accumulation and resilience mechanisms. As Ron was telling you before, that's really what aging is. It's a ratio between the damage accumulation and our ability to repair, eliminate that damage. And then we need to have something that can measure the rate of biological aging, because if we cannot measure it, it will be impossible to understand whether our intervention is effective or not. And then we need to see that this theoretical rate of aging has an effect on subclinical pathology, but we really don't care about subclinical pathology. What we really care is that people are feeling better. So we can look at clinical morbidity and long-term outcomes such as health span, active life expectancy, lifespan, physical function, mobility, cognitive function. And in fact, we start having elements of all these parts. We know what the hallmarks of aging are. We are studying them in animal models, but we start applying and measuring these same mechanisms also in human. Many biomarkers have been studied to look at the rate of biological aging. The most important is probably the epigenetic clock, but more proteomic clocks are coming into the field and are even more promising than the epigenetic clock. our technology to study subclinical pathology is just fantastic. And as I showed you before, we can certainly measure multimorbidity by using and combining some of the information that come from traditional medicine. And, I think that geriatricians and people that do physical rehabilitation have been incredibly talented in studying functional outcomes. So I hope I was able to emphasize and explain to you how this objective is important. And so the overall objective of this initiative is really bold, is to gain 5 additional years of healthy, independent life as measured by the healthy life expectancy data for citizens of the United States by 2035, a significantly narrow health span disparities between disadvantaged and vulnerable groups of the general population. As I say this, I smile. I feel that this is the dream of my life, and if I could contribute to the accomplishment of this goal, it will make me the happiest person in the world. Total medical cost saving will be enormous. This is only a scenario that look at one disease. And the previous speaker was talking about Alzheimer's disease. Of course, we need to study Alzheimer's disease. It's such a destructive disease, but it is possible that Alzheimer's disease is one of the many manifestations of the biology of aging, and that addressing the biology of aging, we can accomplish those prevention of Alzheimer's disease and accomplish the savings that I have outlined in this line. So the goal of this program, increase support for basic and translational geroscience research. And then we need to really push clinical trials. And it will not be enough to provide funding. We need to work on method, change the culture, understand what's relevant, develop outcome, and also make sure that the difference according to race, ethnicity, sex, disability, occupation, and access to care are strongly considered in this clinical trial, right? They are mostly ignored in the traditional clinical trial. And as my predecessor, the previous speaker was saying, it's very important to establish a public-private partnership and innovative program management to address the socioeconomic disparities in research and development, distribution and delivery of geroscience solutions, and speed translation to community in need. And finally, it's important that we create a cadre of researchers that are both expert in clinical geriatric and understand geroscience. These are the doctors of the future. If we don't create a new cadre of physicians that truly understand profoundly what are the principles of geroscience, what are the mechanisms of aging, it will be impossible for them to use the new generation of intervention and drugs that will be developed by this program. So can we really quantify the rate of aging in this period? Can we straight up this curve and have everybody staying healthy up to the end of life? It's a challenge. And I think that we can grab that. It's closer than you can imagine to the future of this country and will certainly affect positively the population of older people around the world. Thank you for your attention and thank you to the previous speaker. I learned incredibly from the previous speaker and I enjoyed this meeting truly tremendously. I'm going to show you one thing, one last slide. I saw this newspaper from Japan that was talking about, the centenarian surge to more than 65,000. And I want to challenge you to ask you, how many centenarians, people over the age of 100 that seem to be wildfire we have in the United States? Many, 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 over 92,000 already. And the number is increasing every day. So when I talk about the aging of the population, it's really happening and we need to speed up to address this problem, because ignoring it will create a lot of issue for the people and for our society. Thank you so much.
Dr. Ferrucci, thank you so much for that presentation, and thanks to all the panelists this morning. That was an extraordinary group, and this has been a terrific session. We're going to take a break here for about 10 minutes or so, and reconvene at 2:45. The next session, we have two sessions this afternoon. The first session is really looking at aging is not the same for every population. And there are great challenges both in the delivery and also in the research area related to health disparities and vulnerable populations. And that's particularly true in the aging population. So we're going to hear a little bit about that, about the steps NIA is taking to address it, about research and disabilities, and about research and vulnerable populations before the afternoon keynote, which will be from Ellis Unger from the FDA, who will, I think, reflect on the FDA has been obviously central to this area and so many other areas, and he's going to reflect a little bit on that. So we'll take a break now, and we'll see you back in about to 2:45 Eastern time in about 10 minutes. Thank you.
So do we stay here?
Anna Maria, everyone can hear us, and you can take a break if you like and come back with a slide will be up for the duration.
Okay, thank you.
And you can, yeah, it's up to you. That went very fast. Welcome back. During the break, one of the panelists who has been listening from Africa made the point that in large areas of that continent in his country, there aren't very few geriatricians. And so approaches that are accessible to broad populations, cost-effective solutions that are approachable to broad populations are important. And I was making the point that that's true in the United States as well. And it's one of the challenges of our healthcare system and our research and development efforts is how do we make sure that these investments reach the people who need them most? And how do we ensure that that the process of developing them gives opportunities to everybody in our country, and they are included in those efforts. And so that's why we thought the next panel was important. And we are terrifically privileged to have kicking this panel off, Patricia Jones. Dr. Jones leads the NIA's efforts to stimulating health disparities research related to aging. She's the director of the Office of Special Populations. In this position, she advances the science of eliminating health disparities, facilitates addressing health disparities through basic clinical and translational and behavioral and social science research, supports developing initiatives that strengthen NIA's research and training opportunities available to underrepresented persons, including minorities and women, and advises other senior staff on health research related to underrepresented populations. She also directs the NIA Buehler-Williams Scholars Program for early career aging researchers. And I am hoping she'll tell us a little bit about NIA's approach to these very important challenges. Thank you so much, Dr. Jones.
Thank you. Is someone able to pull up my slide set?
I'll be doing that for you, ma'am.
Thank you. And while they're pulling the slides, I'll just say it's a pleasure to join you this afternoon. Thank you, Dr. Smith and the planners for this wonderful Geroscience Symposium. I've really been enjoying the remarks shared thus far from all the different segments of the Geroscience community. So thank you. I realize I have just a few minutes, so I will move quickly. Next slide, please. And just preface my remarks with a thought from Louis Pasteur regarding science. And as many of you may be familiar with some of his quotes, him who devotes his life to science, nothing can give more happiness than increasing the number of discoveries, but his cup of joy is full when the results of his studies immediately find practical applications. And it is from this perspective of finding practical applications and looking at the role of team science collaborations and engaging community members as a pathway for helping us find practical applications more swiftly. Next slide, please. So as we've been hearing in our earlier presentations from a number of colleagues, outcomes of health, disparate outcomes, are clearly broader than our biology. And I just share a thought in terms of contextual factors that influence our health outcomes. And so what are contextual factors? Those factors are things that are broader than the external person. They are beyond our individual in terms of health and illness. And they manifest in terms of multiple determinants, either social or physical. Many are probably familiar with the concept of social determinants. Those include things like your social norms and attitudes, whether it's pertaining to discrimination or various options available to an individual or community in terms of transportation or other forms of social support, social networks. But physical determinants also can impact health outcomes, and those would include the natural environment of a particular community, housing, neighborhoods, buildings, exposure to toxic substances and hazardous elements. Next slide, please. And as we were hearing about multiple chronic conditions and broad social factors that may accelerate aging, I just wanted to share a concept with you that may help also further clarify how multiple determinants may influence health outcomes and why engaging community members who have lived experiences in research may be helpful in moving our discoveries to practical application more swiftly. And the idea is called syndemics. One operational definition that the Centers for Disease Control and Prevention offer is it's where two or more factors interact with one another and potentially cause additional burden on a group of people or a person. Other definitions on this topic further define it as synergistically interacting with health problems, coming together and producing additional disease in a population, and that these are various factors that create an additive effect and intensify one another. So when you think, and next slide, please. When you think about the role of multiple determinants of health and the life course or life perspective and how exposure to various determinants over time may influence a person's health outcome, it gives an opportunity for us to think more broadly about the teams formed to explore health research questions, in particular geroscience. Next slide, please. One of the tools that the National Institute on Aging has developed is a health disparities framework. This is a framework that takes into account a number of priority populations by race, ethnicity, sexual gender minority, disability populations, socioeconomic disadvantaged communities, as well as rural geographical areas, and looks at these different life experiences individual groups may have in the context of 4 specific determinants or domains as levels of analysis. And again, in the context of the life course perspective. Next slide, please. And so how this comes together in the health disparities framework, one of the resources that's available is to consider these priority populations as fundamental factors in which we're looking at the levels of analysis more specifically. It offers aging researchers an opportunity to better delineate causal pathways and potentially broaden out the scope of specific targets for a given intervention. It's also an opportunity to remind research teams of the intersectionality of these 4 domains in terms of the level of influence and evaluating how those fundamental factors can actually impact or influence aging, risk of dementia, and how they operate across the entire life course in the context of other diseases. Next slide, please. So as we're thinking about the confluence of multiple determinants that influence health over the course of a person's life, and essentially that our health is broader than our DNA. And there are many studies that document 50% of our health experiences and outcomes can be mapped back to a person's zip code, and 20% can be mapped back to a person's direct healthcare experience or access to care. So when you think about the broader context of how do we go about engaging and leveraging the wisdom and expertise of other persons that may help us better illuminate the question and the strategies used to pursue the question, one approach to consider is the field of team science. Team science is defined as a multidisciplinary group of teams and collaborations. In 2015, the National Academies of Science, specifically the Committee on the Science of Team Science, was convened to explore this topic and better understand how partnerships and collaborations work interdependently to answer important questions. And among those groups are community persons. It's not limited to just specific academic disciplines or professions. To further carry that point forward, Harry Selker and Consuelo Wilkins published a manuscript in 2017 that looks at the intersection of community engagement and team science, coining the phrase broadly engaged team science. And specifically, what they are calling for is looking for scientists and academic partners to look beyond the immediate groups of individuals to collaborate with on research questions and engage community members, patients, and other stakeholders alike in terms of a collaborative shared vision for advancing scientific discoveries. Next slide, please. So as we're looking and exploring fields and opportunities that provide parameters for engaging different types of stakeholders, namely community members, to advance a geroscience agenda, I just offer some general overarching principles for engaging community members. The first is to aligns quite a bit with what Dr. Ye was speaking on earlier in her opening remarks, adopting principles of cultural humility. And cultural humility is really sort of framed in terms of three key parts. One part being open to learning new information and having an open mind that one particular discipline's understanding or body of literature may not necessarily be the sum total of information available to further explain a phenomenon. The second part is to be humble in our level of knowledge and biases, recognizing that all of us are still growing and experiencing and learning information in different ways. And while many of us have worked in different fields for many years, there's still things that we may see differently as we move forward in our careers and have different interactions with community members and other persons. And then the third part is acknowledging institutional accountability in terms of access to care or the lack thereof, and how that may influence a person's perspective or community perspectives around research as a practice. The second piece to principles of engaging community members is identifying the goal of pursuing geroscience with the end user in mind. The third piece is engaging community members as full team members, not simply as a means to an end. Using efficacious models for building community researcher partnerships, and there are several, one of which is participatory action research. Some may be familiar with community-based participatory action research, or CBPR, but there are other types of efficacious models that can be adopted. And then a fifth is considering non-traditional ways for engaging community members in all aspects of developing the study, not simply as a member of a patient advisory group or a community advisory board, but a number of different roles and tasks that they may contribute to. Next slide, please. And so this is simply to illustrate what those roles may look like. And the picture illustrates here roles in terms of level of engagement, but with the context of participatory action research. And so at the very bottom of the pyramid, it speaks to a contribution that's quite important in clinical research and clinical trials and behavioral trials, but not necessarily the most participatory action oriented, and that's being a participant. The next, you have occasional advisors. You may then consider having occasional reviewers, but further along the continuum and more consistent with participatory action research is engaging on a regular and ongoing basis in an advisory capacity, from the conceptualization of a research question to identifying potential recruitment sites, to engaging in materials, teams, and other activities that are germane to clinical and research and behavioral research. And additional roles to consider are also co-researcher and research lead positions. So this is just a few examples of models that have been readily available. Next slide, please. And I'm happy to take questions, but I just want to end my remarks with a comment from Dr. Federica Frigonis. She is a bioethicist in Canada. Some may be familiar with her work, where she notes that the lack of community involvement could result in higher risk of non-respect for the populations living in the research area, greater potential for overlooking important consequences of the research, and limited uptake of results that are not culturally acceptable. And I just offer these suggestions and thoughts as we're exploring geroscience with community members as partners. Thank you.
Thank you very much, Dr. Jones. I think this has been conceived as the beginning of a dialogue, and we wanted to make sure that all the stakeholders at the table, and as Dr. Ferrucci was presenting the goals that emerged in the white paper earlier, the third goal really does have to do with health disparities and addressing those early on and making sure that's a fundamental part of any initiative in geroscience. So very grateful for your participation and contribution. The next speaker is someone who is not only the mentor to Dr. Pasquina, but I think probably mentor to a lot of folks, and myself included. He and his team have been central to this, not only the state of the science in this activity, and I want to just thank Josh Marino, Michael Lane, who are helping with the logistics of this event, and also his wonderful wife, Rosie Cooper. Rory Cooper, Dr. Cooper is somebody who knows all about a lot of things. I have one of his trading cards from the National Inventor Hall of Fame, which gives you some indication. I don't know many people who have those trading cards, but he is the FISA PVA Distinguished Professor, Past Chair, Department of Rehabilitation, Science and Technology, Professor of Bioengineering, Physical Medicine, Rehabilitation, Orthopedic Surgery at the University of Pittsburgh. Rory is an extraordinary athlete as well, and competes in multiple endurance events. He's a wheelchair user. He has a focus on Veterans Affairs and Rehabilitation. As a veteran himself, he's responsible for the creation of the Human Engineering Research Laboratory, the VA Center for Wheelchairs and Associated Rehabilitation Engineering. He's granting veterans access to any assistive medical technology they could need after serving overseas. He holds 25 patents in wheelchair technology, including the MeBot stair climbing wheelchair, the new chair, a chair powered solely by compressed air, the virtual seating coach, which helps control wheelchair from a smartphone. He uses mobility devices and assistive technologies, and they are in part responsible for increasing the quality of life for aging and disabled veterans and other human beings. And it's my pleasure to introduce Dr. Rory Cooper.
Well, thank you very much, Will, for that very kind introduction. I'll try to keep us on track here. Yikes, there we go. There we go. So I was going to talk about the health and aging with the disability aspect. It's been very interesting, the entire symposium, and Will, thanks for again putting this together. And Paul, it's a pleasure to continue to work with you. So first, I give a little plug for AARP. It was great to see on them. They actually featured me as their centerfold in the October of 2020 magazine because I had a very severe accident while doing the Marine Corps Marathon, and the fact that I was healthy and the great care I got from Dr. Pasquina helped me to not only survive, but to recover and continue to do marathons. I would also like to point out, like the previous speaker, that actually people with disabilities are America's largest minority population, representing over 15% of the US population. And it's a growing number, and it's the only minority population that anyone can join at any time, and that everyone's more likely to join as they age. But I also want to show, you can look at some of the images on my slide here, that there are a lot of opportunities to participate in activities for people with disabilities of all kinds and all ages. As a matter of fact, it's a key component of VA and DoD rehabilitation. Unfortunately, less so of rehabilitation in the private sector, which adaptive reconditioning, I think, is a key component. And it's kind of sad that we have lost that in many respects due to the shortening of the rehab time frames. But we do know several things about living with an impairment that affect them, and that also affects longevity post physical disability. And that's is key as well. Some of those are common to everyone, such as family history and income and quality of insurance and personal lifestyle behaviors first prior to acquiring a disability and also after acquiring a disability. And it also depends on the level and the degree of impairment, also the complexity and the type, whether it's a progressive or a non-progressive or not, there's really no such thing as the static, but maybe slowly progressive condition. I should point out too that we try to encourage people not to be risk averse. You can see it in veteran here playing basketball who's fallen down, but is ready to get back up and play again. What we do suspect, I'm always cautious in research about saying what we know because I've had a spinal cord injury long enough to know that exercise was, physicians said that exercise was contraindicated for people with spinal cord injury when I was first injured, and now we have reversed that position completely. So we do know that exercise, most people can benefit from exercise, and but that health, employment, education, income influence health and participation. We have to worry about people being engaged and motivated, which is a problem common to everyone. It's not unique to people with disabilities. What's the challenge for people with disabilities is, it would be obvious from my slides, is that for many of us, technology is critical and access to technology is difficult and costly. Currently, it's only the U.S. Department of Veterans Affairs that provides adaptive sports and recreation technology for physical exercise to eligible veterans. Other members of the community have to pay for it. And if you're watching COVID-19, you know that it's very difficult to purchase a bicycle right now. But even under normal circumstances, a bicycle that's of decent quality would cost about $400. A hand cycle, even just a low-end hand cycle, would cost $4,000. And that's for a population that typically has lower income. And then there are also disparities of availability to programs, access to knowledge, and access to appropriate health care, especially for individuals in certain zip codes, as well as then those could be urban zip codes as well as rural zip codes. And sports and recreation can help with promoting a positive self-image, which we heard earlier is also important for maintaining a longer health span. They're the same barriers are faced by people with disabilities and without disabilities to a certain degree. And that's, but there's the additional ones, availability of programs and equipment, transportation, which is a significant barrier, accessibility features, even though programs are required by the Americans with Disabilities Act to be accessible, many of them are not. And then there could be functional limitations as well as psychological limitations such as depression. I hope you can see by the slides too that you can participate in a variety of activities, and even people with very high levels or complex disabilities can participate in sports like power soccer, or even here we have a triple amputee who's participating in scuba diving or in swimming. I'd like to argue that technology makes a difference. Some things that you might not have heard about is, I'll give you just a few examples of some recent things we've worked on. Go this ahead a little bit. Is on the left is working on suicide prevention. That's a challenge for our people with disabilities, especially as they age. Up on the top is secondary conditions. That's where we show hand cycling and that and ergonomic push rims. It's important. Suicide prevention. So these are some anti-ligation devices we worked on, and masks for people who need to be intubated while wearing a mask. And then that little video clip I showed you is a fuse device for a respirator, where unfortunately veterans got the idea that if they took out the the fire safety fuse, they could, they might get more oxygen, which is kind of a weakness of the misinformation on the internet. And so it was causing deaths among our veteran population, and something that we worked on. So in summary, what I think that it's going to, Geroscience is going to do is help move terminal conditions to chronic conditions. That's what medicine has done for years. Spinal cord injury was a terminal condition up until World War II. Polytrauma was a terminal condition up until the 2000s and in this current conflicts in Iraq and Afghanistan. Diabetes is now largely a chronic condition. AIDS has become largely, or HIV positive is largely a chronic condition now. So we have to be careful about that. Whether things are trauma related. We have to look at capacity to exercise. You saw power soccer, but there are individuals that have very little capacity to exercise and be active in that, but it's still important, and we have to look at that. Improve access to adaptive equipment and facilities and training. Age at onset is important. We're seeing more people acquire physical or impairments as they age, and then look at the different layers of progression and also secondary conditions. And common ones here are, besides the ones that most people would get, but the common related disability or repetitive strain injuries, issues of skin integrity as they change, issues of bone density as they change, risk for metabolic disease, diabetes being primarily one of those, further injuries and accidents. And things we really need to focus on, besides everything we've been talking about today, are access to healthcare, adequate nutrition, adequate or appropriate housing, and providing financial stability, which has really been exacerbated under COVID-19. We've seen that how fragile many people, the lives are, many people with disabilities because of financial instability. We have to get, I really love the thought of the participatory action in research. We call it, in my field, participatory action design and engineering. But knowledge and education are key. Engagement is key. Positively is that many people do now experience normal lifespans. So for example, in my own case, I've had a spinal cord injury for over 40 years. When I was injured, the life expectancy is about 10 years post-injury. So certainly there's been some very important advances. So thank you very much.
Thank you, Rory. Thank you for the talk and for all the terrific work you've done on behalf of veterans. We really appreciate it. The next speaker, Beth Calhoun, is Dr. Beth Calhoun is Associate Dean for Population Health, Professor of Population Health at the University of Kansas School of Medicine. And she's going to talk about the various populations in the United States and aging. She is the Associate Dean at the University of Kansas Medical Center, Professor in the Department of Population Health. She recently served as the Associate Vice President and Executive Director of the Center of Population Science and Discovery at the University of Arizona Health Sciences. She was also professor in the Division of Public Health Policy and Management at the University of Arizona and the School of Medicine. In addition, she served as the Associate Director of Population Science at the Cancer Center. Dr. Calhoun served as Director of the Center of Excellence in Eliminating Disparities, funded by the National Institute for Minority Health and Health Disparities, and was co-director of the University of Illinois Chicago Center for Population Health and Health Disparities, funded by the National Cancer Institute. She led the study to test the efficacy of patient navigation, which is a fascinating program on improving compliance in cancer care in the largest network of federally qualified health centers in the country. She's also a long-term friend, and we're very pleased to have her here today, Dr. Calhoun. Beth, you have to unmute there. There you go. Beth, yeah, just hit the.
Sorry. Okay. It's been said, of all forms of injustice, of all forms of inequality. Injustice in healthcare is the most shocking and most inhumane. And I promise I didn't get with Patricia, with our quotes, the health disparities people, said to us by Reverend Dr. Martin Luther King. So the definition of health disparities and health equity affect how policy is conceptualized. So for policy purposes, you need to distinguish among disparities in health, disparities in healthcare, health equity, and health inequalities. So the WHO disparities definition is difference in health outcomes that are closely related with social, economic, and environmental disadvantage. Yes?
Just a quick question. Do you want to share your screen? Do you have slides you want to share with the group?
Oh, I'm not sharing my screen?
You're not.
Can you see my screen?
No, ma'am. There's a little green button there. It's just at the bottom, share screen.
Oh gosh, sorry.
No problem. These things always happen. We always have. Can you see the toolbar there at the bottom where it says, just hit, and then there, right next to the chat function, there should be a share screen button. There you go.
Okay. All right. Sorry about that.
Oh, before you start, if you could just hit the little, yep, perfect. Thank
Okay. So let me go. So the NIH definition includes special population groups. So I think that that's an important distinction. When you're talking about disparities in healthcare, we're talking about differences in the quality of health care that are not related to access factors or clinical need preferences or appropriateness of interventions. When you're defining health equity implies that ideally everyone should have a fair opportunity to attain their full health potential. No one should be disadvantaged from achieving this potential. Equity in healthcare requires that resource allocation and access to healthcare be determined by health needs. And finally, the WHO health inequity definition is health inequities are systematic differences in the health status of different population groups. And these inequities have significant social and economic costs. So during the Affordable Care Act in we had a significant reduction. I did a lot of work in this area in Illinois and actually helped roll out the ACA navigation training. So we saw a significant reduction in uninsured rates, and to, as Rory's point about access to good quality health insurance is important, but we see real differences in still in the rates by race, ethnicity. So addressing health disparities is going to become increasingly more important as it's projected by 2050 that more than half of the population will be persons of color. And as I mentioned in the previous slide, as of 2018, Hispanics were 2.5 times more likely to be uninsured than whites, with incomes below poverty, and they're 4 times as likely to lack coverage as those with incomes of 400% of the poverty level and above. So the Commonwealth Fund, this is in terms of the cost of health disparities to our country. They reported it, healthcare costs represent about 17% of our GDP, or more than $9,000 per person. This is nearly 50% higher than other developed countries, where the average is between $3,000 and $6,000. And sadly, the most recent estimate that I can find in the literature, and this is, I've had this on the slide for a long time, and I thought somebody would have updated this report, but the estimate for eliminating disparities for minorities would have a reduction in direct medical expenditures by $230 billion, and the indirect costs associated with illness and premature death by more than $1 trillion. And this was adjusted 2008 inflation rate dollars. So health disparities have a huge impact on our economy and our health. And in 2020, it's estimated that that an additional 3.6 million years life were lost due to the high percentage and excess death rate in the US driven by racial disparities. Hispanic people had over 3 times the premature excess death rate in the US than among all the other groups. And 30% of the excess potential years life lost in the US were among African-American people. So achieving health equity, I think, is certainly something I've been researching for my entire career. And it's important to point this out. The worst health outcomes occur in areas with other economic and social disadvantages, right? So where, mortality and crime and all overlay and intersect. But in order to really facilitate health equity, an investment would be, result in improving the slope. So you need to have more improvements in the disparity populations in order to achieve equity. So it's called the slope index of inequality. And so I hope that today is a begin for a call to action. Thanks, Will.
Thank you, Dr. Calhoun, very much. So I think we've covered 2/3 of the program, and we have a final piece here, which is, which I will introduce Dr. Fleming, who will introduce our final speaker, Dr. Ellis Unger from the FDA. And Dr. Fleming has run for many years one of the most important gatherings on the topic of aging and disease. He coined a term, metabesity, to describe the metabolic impact of aging. And he has run a meeting in Washington, D.C., which I've attended, which has brought together many of the leading thinkers. He is the founder and chairman of Connexium, which is a strategic advisory firm. He was at the FDA from 1986 to 1998, was responsible for landmark approvals of the first statin, metformin, and other endocrine and metabolic therapies. He represented FDA at WHO and international conferences on harmonization. He coined the term metabesity, as I mentioned, which describes the constellation of major chronic diseases of aging process itself, which all share common metabolic root causes. He organized the first Congress on metabesity in London in 2017 and has had the annual conferences in DC. He founded the not-for-profit Catalyst Institute as a means to produce metabesity conferences and advancing inventions of any kind that can improve the health and health span. My pleasure to introduce Dr. Fleming.
Well, thank you very much, Will. It's my honor to participate in this distinguished conference, which is part of the Moonshot-like program to increase health span and to slow or prevent the major age-related chronic diseases, cancer, and the aging process itself. I'm so glad to introduce Dr. Ellis Unger, who you will quickly understand is uniquely qualified to provide a perspective from FDA on the subject of therapeutic products for preventing major age-related chronic diseases. Dr. Unger, a cardiologist, is director of the Office of Cardiology, Hematology, Endocrinology, and Nephrology in the Center for Drug Evaluation and Research, CDER, at FDA. After completing his cardiology training at Johns Hopkins in 1987, Dr. Unger led a translational research program on promotion of angiogenesis as a senior investigator in the cardiology branch at the Heart Institute, NIH. He went on to serve as a medical officer, team leader, and subsequently branch chief in the Center for Biologics Evaluation and Research at FDA, CBER. And after regulatory authority for therapeutic biologics was transferred from CBER to CDER, In 2003, Dr. Unger joined CDER as the Deputy Director of the Division of Cardiovascular and Renal Products. He later went on to become responsible for oversight of not only that division, but also for the Division of Neurology Products. Dr. Unger is now responsible for oversight not only of his former division, the Cardiology and Nephrology Division, but the divisions of Diabetes, Lipid Disorders, and Obesity, Division of General Endocrinology, Division of Non-Malignant Hematology, and the division that supports toxicology evaluation for all those review divisions. And so you now understand that Dr. Unger has responsibility for therapeutic evaluation of most of the chronic diseases which are being targeted for prevention. So his experience and understanding are not just highly relevant, they are broad and deep. So thanks so much, Ellis, for being here today.
Thank you very much for that introduction, Dr. Fleming. I appreciate it. I'm going to try to share my screen here, see if this works. You're going to have to let me know.
It works.
Good. Well, as Dr. Fleming mentioned, I have a lot of ologies, but one of the ologies I don't have is agingology. So I'm no expert on aging, but I was intrigued by the opportunity to give this talk today, because obviously it's something we need to think a lot about at FDA, and the various divisions I oversee do have a lot to do with regulating drugs for the chronic diseases that plague those of us who are lucky to reach higher ages. Now let me see if I can control the slides. There we go. I usually just blow right by the disclaimer, but I will tell you today that these are my views. The FDA really hasn't espoused any particular views on aging. We have no guidance. It's new. So please accept the fact that these are mostly my own views and opinions. So everyone on the line knows what aging is. It gradually and progressively affects most organ systems. There are a number of features, and I've listed some of the organ systems here: brain mass, cognition, coordination, the function of the bone marrow, renal function, function of the skin, its thickness, elasticity, sensation, sweat production, pulmonary system function and lung surface area, muscle mass, strength, mobility, balance, and sensory inputs are all, unfortunately, things that start to fail when we age. So what's the goal here? Well, I didn't coin the phrase successful aging, and it's not an FDI term either. You can find it on the web. I think I found it on UpToDate. But successful aging means that older individuals are free from chronic disease. They continue to function well, both physically and cognitively. And I think we would all agree that the goal is to enhance health span, the healthy, active period of life with a shortened period between critical illness and death. That's the goal. And there's quite a bit of interest in preventing the typical morbid events of aging, so stroke, diabetes, et cetera. But what I want to spend a bit of time talking to you about is what a therapy for aging is and what it is not. So the question here is, if a treatment prevented those events, would it constitute a treatment for aging? And many of you might say yes, but I'm going to try to convince you otherwise. So this is my own little diagram representing a person who ages successfully. And you can see quality of life on the ordinate and age on the abscissa. And you see the function improves and then gradually declines, and it goes to 0 at death, this person at age 90. So let me superimpose on this individual a heart attack, MI, at age 55. And you see there's a sudden, there's a precipitous drop in quality of life, but then there's good recovery, but not complete recovery. And you see the person goes on to live till age 90, despite the heart attack. So the life was not shortened, but the quality of life was reduced. Okay, so if a drug had prevented this heart attack, would it qualify as a treatment for aging? So I have a hint here, which is that there are many drugs that actually have indications for the prevention of heart attack and stroke, cardiovascular death, but they don't have indications for aging. So there are many examples. So drugs for the treatment of hypertension, hypercholesterolemia, and diabetes have claims for prevention of heart attack, but not for aging. So let's take this hypothetical patient and superimpose another problem. At age 80, there's a fall and a hip fracture. And look what happens to this hypothetical patient. There's an immediate loss of quality of life with some recovery, but then quality of life takes on a different slope. And life is actually shortened. So there's about a 5-year loss of life here. And we're going to attribute it to this hip fracture. So the question then is, if a drug had prevented the fracture, would that qualify as a treatment for aging? And I'll tell you, the hip fracture may have shortened the life of this individual. And the hint is that we have some drugs for the treatment of osteoporosis, and they have indications for prevention of fractures, but not an indication for aging. Okay, we recognize that there are many diseases that occur more commonly with age. Actually, we've seen some beautiful slides on this, wonderful slides, actually, and I don't need to go through these individual diseases. But the onset of such diseases and conditions are not tantamount to aging, though older individuals are at higher risk. Such diseases can cause specific events that punctuate the course of aging. They can lead to accumulating disability and certainly reduce quality of life, but they don't represent aging per se. So it follows that reductions in the incidence and or severity of diseases associated with aging, for example, MI, fracture, Alzheimer's, should not be construed as effects on aging, though such events decrease the probability of successful aging. So it's a bit complicated here. So now I'd like to talk to you about developing drugs for aging. This is one regulator's view. I did run this by several people at FDA and got agreement. Actually, some of the people were pretty high up. And so this is probably pretty representative of our view. That is because aging is a systemic process. A successful treatment would delay, arrest, or reverse the aging process across multiple organ systems. Okay, my own view is that a drug, in order to obtain an indication for aging, the expectation would be that salutary effects would be observed across a wide range of parameters that are known to occur with aging. Dr. Robert Temple, who was my mentor and is the deputy for clinical science in Cedar, gave a talk 6 years ago and said, quote, "One would have to believe that effects on a group of seemingly unrelated illnesses would begin to make the case for the broader concept." So again, we're looking for broad effects. But you need to recognize that we want to approve any drug that actually makes a difference. So if a treatment makes a difference in a disease, if it improves the way patients feel, function, or survive, FDA will approve the drug if the benefits outweigh the risks and we can write labeling that provides adequate instructions for use. And the mechanism could be anti-aging, it could be health span extending or some other mechanism, and we don't even have to know what the mechanism is. It doesn't have to be known. So how would we get a drug approved for aging? Well, in any drug approval, the development program involves various endpoints, and I'd like to discuss those. So I'm going to take a little bit of a dive here. Bear with me. I'm going to talk about 3 kinds of endpoints. There are clinical endpoints, surrogate endpoints, and biomarkers. So a clinical endpoint reflects how patients feel, function, or survive. It's a clinical benefit. It's not a number. It's how the patient feels or does. A surrogate endpoint is thought to predict clinical benefit, but is not itself a clinical benefit. So it's generally a laboratory measure or an image, something like that. A biomarker is a sign of a normal or abnormal process, condition, or disease. Much like a surrogate endpoint, it's generally a laboratory measure, a molecule or an image, something. And it can be used to assess responses to treatments. but the data are not sufficient to consider that marker predictive of clinical benefit. Okay? And then surrogates can be subdivided. And this is very important. A surrogate endpoint may be known to predict clinical benefit. And if it is, we call that a validated surrogate endpoint. And that can be used in lieu of a clinical endpoint for a traditional, regular drug approval. So for example, we are so convinced that LDL cholesterol concentration is tied to outcomes that that is a validated surrogate endpoint. The same with blood pressure. Many drugs across many drug classes have been shown to decrease predominantly strokes and heart attacks. And so we simply accept the fact that blood pressure matters. It's a surrogate endpoint that is validated. The same with hemoglobin A1C and diabetes. Another type of surrogate, second bullet, may be deemed reasonably likely to predict a drug's clinical benefit. And these can be used as a basis for accelerated approval. So these are, for example, total kidney volume for polycystic kidney disease. And third, there may be insufficient evidence to support reliance on the marker as either of the above. So that kind of surrogate can't be used to support either type of approval. Whoa, I hit end. Sorry about that. Wrong button. Okay, sorry. I'll show this kind of graphically. So the clinical endpoint and the validated surrogate endpoint can be used for traditional approval. The surrogate endpoint that's reasonably likely to predict clinical benefit for accelerated approval, and other surrogates and biomarkers are good for proof of concept, hypothesis generation, dose ranging, etc., but not for any kind of approval. Okay, the FDA recently published a table of 121 surrogate endpoints that have been used previously, and I'm a little short on time. I will simply reference this and show you the
Doctor,
URL. Yeah.
please take your time.
Please take my time. All right. This is actually a wonderful table, and it shows you the various endpoints, 121, and which ones were used for accelerated approvals, which ones were used for traditional approval. It's quite valuable, actually. I had never seen it until this week when I was putting this talk together. And apparently it was put together to fulfill the 24th Century Cures Act requirement. I wasn't aware of it, but it's a wonderful table, and I'd like to direct you to it. Let's go back and consider the effects of aging and think about endpoints. So we have loss of brain mass, cognition, coordination, bone marrow function, immune function, hematopoiesis, renal function, etc. All of these seem plausible as bases for endpoints for drugs for aging. And there are certainly others. There are plenty of others, but they all seem like fair game. There are, again, clinical endpoints and validated surrogates and unvalidated surrogates. So the clinical endpoints, again, how a patient feels, functions, or survives. So the ability to perform activities of daily living, very important. How long does it take you to put on a shirt or button a collar, tie a tie? Cognition, coordination, mobility, balance, muscle strength, exercise capacity. How often do you fall? How well does your skin sensation work? Olfaction, your hearing, incidence of infections, probably a fair reflection of immune function. So those would be clinical endpoints. There are some validated surrogates. They haven't been used in aging, but they've been used for other indications. So creatinine clearance we use for drugs to prevent or delay the onset of kidney disease. Hemoglobin is used for anemia. Pulmonary function tests are used for various drugs that are for pulmonary diseases. And bone mineral density is a surrogate. Actually, I'm not sure that it's validated. I'd have to check on that. But that's a surrogate if not validated. Unvalidated surrogates would be things like brain volume, skin elasticity, sweat production, muscle mass. You know, you can measure muscle mass pretty effectively. It doesn't necessarily relate to how a patient feels, functions, or survives. So it's not validated, but it's suggestive. And then there are many biomarkers. Now let's be realistic about developing a drug for aging, because aging takes time. I know some people think this could be done quickly. I'm not sure how quickly it could be done. Here's a hypothetical. This 3.2 unit change takes 4 years. And that's not so easy to detect because if you have a 3.2 change over 4 years in the placebo and the relative treatment effect is 50%, which is large, you know, decrease aging by 50%, the absolute difference, the treatment effect that you need to discriminate is half of 3.2, which is 1.6. That's not easy to discriminate because variability in aging and variability in the clinical measures of aging, a study that's only a few years in duration, you know, may not be fruitful. So it's a major challenge. But we have an answer for that, and that is called accelerated approval, which is well suited for treatments for slowly progressive diseases. And I don't know whether aging is a disease. It's a condition, I guess, but it's certainly slowly progressive. And so when developing drugs to treat or prevent slowly progressive diseases, the trials can take a long time to complete. And so in those situations, there's a desire to accelerate the availability of drugs. We have a guidance on this with the URL at the bottom, and it's all about accelerated approval. Accelerated approval is applicable for serious or life-threatening disease, where the treatment offers a meaningful advantage over available therapies. And in the case of accelerated approval, the approval is based on a surrogate endpoint that is thought to be reasonably likely, I'll repeat, reasonably likely to predict clinical benefit, but is not itself a measure of clinical benefit. And if you gain accelerated approval, post-marketing confirmatory trials have been required to verify and describe the anticipated clinical benefits. So the idea is you approve a drug on a surrogate endpoint, but a confirmatory trial needs to be done to verify and describe that benefit. And that trial should actually be enrolled at the time of accelerated approval. And accelerated approval could be used for drugs for aging. The approval could be based on one or more surrogate endpoints that reflect multiple aspects of aging and are deemed reasonably likely to predict clinical benefit. One could construct a composite endpoint that assesses parameters of aging that could be measured with good precision. Some could be clinical, some could be validated surrogates, and some may be unvalidated surrogates. So glomerular filtration rate is a validated surrogate for how well your kidney works. Brain volume is not validated, but it certainly seems compelling. I think one could make the case that brain volume matters. Muscle strength is in fact a clinical endpoint, and obviously there are many others. One could also do a traditional approval. It's not an accelerated approval, so regular approval that's based on a clinical composite endpoint. Again, the problem is, you know, if you're trying to beat a placebo group, the only way you show a treatment effect is if the placebo group declines during the interval of the study, and people don't decline that much in you know, a few years, but they do decline some. So you could overcome the noise with numbers. You know, larger numbers in the trial. And these are pretty much all clinical endpoints or validated surrogates. So the activities of daily living, there are neurocognitive tests, tests of coordination, mobility, balance, muscle strength, exercise capacity. Again, how often do you fall? Falls are terrible in the elderly. Olfaction, creatinine clearance, pulmonary function tests. My conclusions. One, aging is a difficult indication to study. The process occurs at a slow rate and there are no validated surrogate endpoints for aging. Two, aging is an easy indication to study. First, there's great interest in the scientific community, obviously. There are great financial incentives to develop drugs. There are many measurable parameters to assess, and there are millions of subjects to study and more every day. We don't hold all the answers, but we do hold some of them. We're not a bunch of pinheaded bureaucrats at the FDA. We have good scientists here, and it's our responsibility to facilitate these studies to the best of our ability, and we're here to help. So please feel free to contact us. And I thank you very much for your attention.
Well, Ellis Unger, we can't thank you enough for that very helpful presentation. And Will, I believe we have a little time for discussion. Maybe we could take questions from the chat, or if you otherwise want to recognize people from the floor. I'll just begin, Ellis, by putting forward the concept of a composite that might be more sensitive to an effect than measuring any particular, let's say, preventing just cardiovascular disease, or in other words, a composite of multiple chronic diseases. Whether this could be a suitable endpoint for basing a so-called health span claim. After all, health span is defined as the period free of chronic disease. So it could be a time to event analysis of chronic diseases occurring, starting in a otherwise healthy population.
Yeah, well, so I would say that, you know, as I showed in my slides, if you take a healthy person and they have a heart attack, and you make them have it later, it's not because you affected aging so much as you prevented the heart attack, and you get a claim for that. There are initiatives, there's certainly one initiative to roll into a composite endpoint multiple clinical events. So you roll into that hospitalization for serious things, a heart attack, stroke, death, onset of Alzheimer's disease. You could, and people are doing those kinds of trials. Whether that actually reflects an effect on aging, I don't know. But if you did such a trial and the trial were successful, you get a claim. It might not say aging, you know, but if you delay the onset of cardiovascular diseases and Alzheimer's, you get a claim because we want to approve that drug. I just don't know that the claim would say, you know, aging. You could though maybe roll that kind of endpoint together with the other kinds of things. For example, the estimate of you know, glomerular filtration rate from the serum creatinine, pulmonary function studies, things that are measurable that we believe, and physical strength. And I think if you maybe had a critical mass of endpoints in that composite, you might be able to do a trial like that and convince us that the word aging belongs in the indication. But again, I'll stress, if you prevent cardiovascular disease and Alzheimer's and falls, you'll get a claim. I just don't know whether aging will be a word that's in that claim.
I have a question here from the audience here. What is the path to validate surrogate endpoints for aging?
We have a whole division devoted to that. I believe the name changed recently, so I'm reluctant to give it to you. I can't give it to you. We've had a reorganization, but the person to contact is Dr. Jeffrey Siegel. And he is in charge of biomarkers and the qualification program. That we have an entire program dedicated to qualification of biomarkers. I just can't tell you the name of it anymore. But he's in charge of it.
Thank you. Another question, since much of emerging geroscience elucidates molecular and cellular excursions, is there any way the FDA consider interventions designed to fix the hole before it leaks, i.e. before very large, very expensive trials that show effect on fetal function survival? Not sure I totally understand. Does this depend on validation of biologic clocks or other biomarkers of aging? Well, it sounds like surrogate endpoints or.
Yeah, I mean, this is a biomarker or surrogate endpoint, and these things are important, and they may in fact hold the key to maybe what Ponce de Leon was looking for. But the trials that we're talking about don't have to be, they may have to be large, but they don't have to be expensive. So if you need to enroll 20,000 patients in a study in order to show efficacy, you don't necessarily need to monitor all 20,000 patients very well. So once you monitor 1,000 patients well, you can really cut down on the monitoring for the rest of the population. We don't need 437,000 blood tests, CBCs, to figure out if a drug is safe. So we can kind of divorce the efficacy from the safety and try to make the trial as simple as possible and try to collect endpoints even over the internet. And that's something I think we've all learned in the last year, that we can do these things on the cheap and actually get better information because we have fewer missing data. So they don't necessarily have to be, incredibly expensive, even if they're large.
Very good. Do we have other questions for?
Well, we do have a question, Will, about or noting that senolytics and cenomorphics are under IND and being developed. Now, these are going to be, in effect, means of reversing aging or dysfunction related to aging. So those may be easier to actually measure a benefit, given that there would be dysfunction to start with, and you'd be able to measure an improvement. Any comments about that distinction? For example,
I'll disavow knowledge of any INDs. But yes, obviously, if one could arrest or reverse aging, then you need a smaller sample size and or a shorter study. I think, though, because reversing aging is novel, you're going to need to have obviously substantial evidence no matter what. You're going to have 2 trials. But anyway, you're making the point, the sample size would be smaller if the effect size is larger.
Right. We have drugs, as you mentioned, that are approved for osteoporosis. We don't have any therapies that are approved for the analog related to muscle, sarcopenia. Can you envision, as a kind of stepping stone indication, sarcopenia being targeted as an indication, if there's some degree of function or other clinical value that is wrapped in with it?
Yeah, definitely. It's an important facet of aging. I have it and don't much like it. And yeah, sure.
All right, well, there may be some sarcopenia mavens in the audience who'd like to speak up, but let's see, any other?
Pasquina here, I think are you unmuted, Dr. Pasquina?
Yeah, no, I was just wondering, Dr. Unger, we had some talks earlier about the development of an ARPA-H and what type of relationship might you foresee between this ARPA-H organization and the FDA, and if that would create greater demand on the FDA, whether it be across, drugs, devices, or surrogate biomarkers. Just your thoughts on that.
I mean, we can absorb some degree of greater demand. That's not, we do that often. In terms of collaborating, we always want to collaborate with stakeholders, professional societies, patient groups. So there is the opportunity to collaborate. It's not like when I was at NIH, I was involved in some CRADAs. Those are rare at FDA. But certainly we would be pleased, I think, speaking for some people who may be above my pay grade, in collaborating.
Well, we're so grateful for your time today. We have a few of the panelists here. If there's a question for the other panelists, we can take it before we wrap up. Otherwise, it's been a really fascinating group of speakers. I can't tell you how many messages I've gotten here. just complimenting every one of them.
I was hoping to get a message from my father on the chat because he said he was going to listen. He's,
Do you answer questions from your dad on the chat?
he's 99 and a half years old.
Oh.
Oh my gosh. That's I see something showing up here.
Yeah. Okay, Dad, if you're on, did you like the talk? No. He probably got bored with it.
I think you're a poster child for healthy living, Ellis.
Well, I try. I take a lot of drugs to prevent those, you know, the events that punctuate chronic disease.
You know, coming here and making yourself available and putting yourself, you know, out for the process that led up to this has been really appreciated by everybody. And as I think I've written you, your work is so important. I know you've been there for 20 years. It's so important to, obviously to this field, but to the health of the nation. So thank you for that service, and thank you to all of the incredible panelists and the participants who have come and stayed for this Geroscience Symposium. We're very grateful. We have some follow-up things that will happen. I think probably there is a white paper. We have acquired the URL geroscience.health, and I think we will be posting some proceedings things on that URL, our white paper, some of the proceedings from the 2019 conference that was held at USIS, which is currently the focus of a special edition in Geroscience. We will have some follow-up thoughts about perhaps a letter that maybe folks can sign supporting additional federal investment in this area. And of course, I'm speaking here as a private citizen, and other things. So we look forward to a continued dialogue, developing some of the ideas and concepts that have been laid out here today. And we are so grateful for the time and energy that everybody's put into this. And it's a very promising and I think important meeting. Thank you so much.
Thank you. Thanks so much.
Thank you.